Now let us install MySQL. Let us first download it on a Windows machine. Open your browser and go to the site mysql.com. Now go to the downloads page. Scrolling down, you will find MySQL Community GPL downloads and Community Edition, which is free. Here you will see the recommended installer for Windows. Generally, you will find two options. One is the web version and the other is offline installer. Web version will download the tools and updates over the web and will install it, whereas the other one can be installed offline. Here we are downloading the web version of it. Okay, now the file is downloaded. Let's get started with the installation. Double click on the downloaded file and provide the permission if prompted. Here it will ask you for the setup type, in which we are going to select developer default, as this contains all the necessary configurations for development purpose. You can go through the description for more details. Now click next. Now this will download all the required products. Once this is downloaded, click next, and now you can see we have the products here ready to install. Click on execute. Now this may take some time to install. In the next step, we will have to select the machine type, in which we are going to select the developer machine, because we don't want MySQL to take up a lot of memory. Here we don't have to change anything else. Click on next. In next step, we are going to select the recommended option for authentication method. That is, we are going to use strong password. Next. Provide the strong password which you can remember. Next screen is for Windows service configuration. Here is the name by which this service will be installed in the system, MySQL 8.0. This you can find in the services.msc once this is installed. Click next without any further changes. This will apply the configuration and start the setup. Once done, click finish. This will take you to router configuration. Here we don't have to make any changes and click finish. Now we have connected to server. From here we can verify if the server has been installed correctly. Enter the password that we have provided during the setup, and now we will click on check. If everything goes right, we will be able to connect successfully. Click next and finish. Here we have successfully completed the installation. Now you will see MySQL Workbench and a connection by default. If not, then click here. Give a name for the connection and store the password you set in the vault by clicking this. Check the connection. Click OK. A new connection is added. This was for Windows, and now let us install MySQL on a Mac machine. Now let's get started with MySQL installation on Mac machine. To download MySQL for Mac, we will first go to mysql.com, click on Downloads, navigate to MySQL Community GPL Downloads, and now we will click on MySQL Community Server. Here you can see different options for different OS. Here we will select Mac operating system, and now in second option you have different OS options. Here I have Intel system, so I am selecting second option, that is Mac OS 11 x86 64-bit. Now select the DMG archive file and click on download. Skip the sign in option and click on no thanks, just start my download. Let the file be downloaded. Once the file is downloaded, double click on the downloaded file, which will open up the .pkg file and then click on the .pkg file. This will open up the installation window. Click on Continue. Agree terms and conditions. In next screen, click on Customize to see what all components will be installed. You will see here we have MySQL Server, Preference pane, Launched support already selected. You can select MySQL Test. This will create a sample database named Test. In Action pane, you can see it is showing upgrade. That is because I have a previous version installed on my system, so it is asking for update. If you are installing it in a fresh system, it will show you install in action. Now click Install. Enter your system password if prompted. This might take some time for installation. Once done, in next step it will ask you to create password for root. Here we will select the use legacy password encryption. Click on next and enter the password which you can remember, and let's finish. If prompted, enter your system password. Once the configuration is done, click finish. This will open up settings pane for MySQL. To check the installation, we will open MySQL Workbench app and create new connection. Give a connection name. Host name we are going to say localhost and port will be 3306. Password. Click on Store in Keychain and enter the password provided during installation, and there you go. From here onwards, we will be using SQLYog. It has very user-friendly and clean interface. Also, it has profiling features, schema comparison, etc. It has both community and paid version of it. Here we will be downloading the community version. Installing SQLYog is simple and straightforward. Download and follow the on-screen instruction. To download, we will go to this link and click on the link SQL Community Edition. After this is downloaded, just double click and follow the on-screen instruction, which is basically next, next, next and finish. Now we have to give the connection settings. First, give a name to store and settings by clicking on New. Once done, you have given the credentials. So in host, it will be localhost or the IP if we want to access remote server. In our case, because we have MySQL installed locally from our previous session, we are going to use localhost. Username by default is root, so we don't need to change anything here. Password is the one that we had provided during the MySQL installation. Port again that we have provided during the installation by default, which is 3306. And lastly, connect. Now it is asking you to save connection, so click on yes and it is done. Now that we have installed SQLYog and we will be using this IDE throughout this series, let's have a walk around on the IDE. Let's start SQLYog. The first screen that we see here is the connection screen. Here we will have our stored connection. You can see here during the setup, the connection we have stored is displayed. Now even we can add new connection. Let's say, for instance, I am creating one more localhost connection with different connection name. Let's give it the name my first connection and input all the required details. In our case, everything will remain the same and I enter the password and let's save this. Alright, now on the left panel we have a list of database for the selection connection. On the top, you can see which connection list we are connected to. I am expanding the database and you find the related tables, views, functions, stored procedures, triggers, and events. On the top right part, we have a place to write the queries, and on the bottom is the place of the result of the executed queries. On the top, we have buttons to open or create a new connection, new query tab, execute all queries, execute and edit, refresh, and then we have database selection as well. Now these are the buttons that we will use very frequently. Others are for database administration part like backup, export, import, database synchronization, which we will cover in forthcoming lectures. Now once we click on any database, that database gets selected for the query. It means any query that we will execute will refer to that selected database. Here what you see are the default databases and tables. For example, now in this world database, in tables we have city, and in SQLYog database we have actor table in it. Now if I select world table and write a query, let's say select star from country language, and I put a semicolon. So semicolon here will tell the IDE that the query ends. So now let's execute. Now we have the result below. Let's change the database selection. Click on the SQLYog and execute the same query. Though the query is right, but it will give error as now it is referring to SQLYog database, which is not having country language table in it. And the same error can be seen in the result as well, that says table SQLYog.country language does not exist. Now let's try to write multiple queries and execute them. Let's select the SQLYog table and write down two queries. I'll say select star from actor and select star from address. Let's first run single query and you get the result. And let's execute both the queries also. I'll click on execute all queries and you still get the result for both the queries. In first result tab, we have the result for first query, that is select star from actor, while in other tab we have result for another query, that is select star from address. Now as I said earlier that semicolon tells the IDE that the query ends here. That means if I remove the semicolon from these queries and execute it, this will give us an error. And once we put the semicolon, we are good to go. Also, we have a history tab which keeps a list of all the executions. The good part of this IDE is that we can have multiple database connections run at the same time. So we can have different connections here. Let's click on this add icon and it will ask you to open a connection. From here you can select the connection you want to open. Let's select the other connection that we have created here. I select connect. Now we see that we have two different tabs with different connections. Let's run the query in the new connection tab. I'll select world database and let me say select star from city. So now both the tabs have their own queries and results. The good part is that this IDE saves every session endpoints. It means for any reason, if there is a system failure or we have mistakenly closed the IDE, next time we open it, it will resume from the last session that we were at. For example, let me close this IDE here. And now if I open, you see that both the tabs are intact with the queries in it. Here we also have the option to edit the results. Just click on the drop down and select the table from the drop down. Also in the left corner we have the option to export the table data in some very infamous extensions. I'm just joking. Very famous extensions in fact, like CSV, JSON, XML, SQL, etc. These are some basic query execution parts in this IDE. We will get more in depth as we proceed further in the series. Now that we are ready to start storing data, we first need to create a database. Before we create a database, there are few things which we need to know. These are not that important as we don't use them explicitly in creating database, but it's good to have this information. The information is about the character set and collation. A character set is a set of symbols and encodings, and collation is a set of rules for comparing characters in a character set. Collation tells the database how to perform string matching and sorting. One character set can have multiple collations. Let's make the distinction clear with an example of an imaginary character set. Suppose that we have an alphabet with 4 letters, capital AB and small ab. We give each letter a number. Let's say A is equal to 0, B1, A2 and B3. The letter A is a symbol, the number 0 is the encoding for A, and the combination of all 4 letters and their encodings is a character set. This is just an example. In real life, most character sets have many characters, not just A and B, but whole alphabets, numbers, sometimes multiple alphabets, and Eastern writing systems with thousands of characters along with many special symbols and punctuation marks. To check the list of character sets available, we have the show character set command. This will show us all the available character sets with its default collation. To get list of collations, we have the show collation command. To show collations for any character set, we have the show collation where character set is equal to UTF-8MB4. And to check the default collations, we will write query, select character set database, comma, collation database. So now when we create database, our default character set will be UTF-8MB4 and collation will be this one. Usually the default collation is decided based on the regional settings of the server, but in most cases it is UTF-8MB4 as it covers almost all the language support. Only for a few languages like Chinese, Russian, German, we have to use language specific character sets. So now let's create a database. Let's first create database using SQLYog GUI. On left panel where we have list of databases, right click on root node and select create database option. This will open the create database pop-up where we have to give database name, let's say employee. And also we have the option to select character set and collation, which we will leave it as default. Click create and done. Now here in the left panel we can see we have our database created. Now let's try to create database using command line. Open MySQL command line client. Enter the password that we have provided during setup. Now we are good to start with writing commands or queries. Let's check the list of databases first. To do so, we will write show databases and semicolon. I press enter here. So here we have the list of databases. In command line, to end the statement, semicolon is important, which we have already discussed in earlier sessions as well. For example, if we just write show databases and do enter, it will ask for a new line. It will not execute unless we put a semicolon. So put a semicolon and here we go. Let's try to create new database from command line now. So the command would be same, create database employee. Now because we already have a database named employee in our database list, this will throw us an error. And this you see that it shows database exists error. To bypass this error or instead say MySQL to create database only if it doesn't exist in the database list, we will write create database if not exists emp. So now if the database already exists in the list, instead of error the query will execute but with warnings. To check what was the warning, we will have to query show warnings and a semicolon. This will always list down the last warning. Now let's try to create a database which is not in the list. Create database if not exists employee and I press enter. So the query is executed successfully. Now let's check the database list if the database has been created or not. Let's write show databases and press enter, and we can see our newly created database in the list. A drop database statement is used to delete the existing database from the server. So basically the drop database statement first drops all the tables and then deletes the database permanently and cannot be undone. So we need to be very careful before using this statement. So this is how you drop the database. You say drop database and the database name. So let me first create one database here. I'll say create database, drop database example. Let's execute and let's check the database list now. I'll say show databases. And we see that the database is created a moment ago. Alright, now let's drop this. So I'll write drop database. If exists, then drop database example. If exists here is an additional check so that MySQL doesn't throw an error if database does not exist. Let's execute this, and once again let's execute the show databases, and you see that the database does not exist anymore. To store any information in a table, we need fields, and every single piece of information that is stored in the fields need to have a data type. So when we create a table, we have to give the columns. Say we are creating a customer table which has a field customer_ID. So just giving the column name is not enough for the table. Following the column name, we have to put the data type of the data which is going to be stored inside that column. So think about having a table, one of the column customer ID. Every single value for this column, every single row will have a data of certain type, that is data type. Now what is the benefit of this? Well, if the table has all of the same type of data for a column, for example, all columns are numeric, then the data manipulation will be faster, storage will be optimized, and it will restrict incorrect data. That is, the data that doesn't fit into that data type will be ignored. But before we jump ahead, did we really figure out what data type is? A data type is simply a type of data, that's it. But jokes apart, it is very important to define proper data types to table fields for overall optimization of the database. These types of fields or columns are referred to as data types. MySQL uses many different data types which are generally broken into three main categories. The first is numeric, second date and time, and third string types. These are the three main categories that we start with, and then later we learn some more. In each of the categories, there are some specific data types that we are going to learn about. But if only talking about categories, what determines a numeric data type? Well, that's actually anything dealing with numbers. Means any number that has actual numeric meaning like IDs, prices, quantities, salaries, discounts, etc. Next is date time. It's pretty straightforward, anything that has to deal with date or time or even date time together. And the last one, string, which can contain anything like a number, a string, a statement, a symbol, new line characters, and even different language characters. When I say number, it actually stores the value as string only. And one last thing about data types is storage or the size. That means certain data types allow you to change how much data we can store in that column. That is, you should only use the type and size of the field you really need. For example, if you know that the field is going to contain only 2 characters, there is no point in defining a field with 10 characters. Now let's talk about the relative question. So what is the concept of data type and why do you need to define it with columns? Well, when you store data in a column, you need to mention which type of data will be stored in that particular column. By giving data type, you are informing the database about type of value. For example, name is a string and price of a product is a number. If price is not mentioned as number, it won't be possible to perform numeric operations like total or maybe discount. So you make sure that type of value which the column is going to hold, that needs to be properly defined with the data type. Let's discuss numeric data types in detail now. Following are the common numeric data types. Note that MySQL performs rounding for all numeric data types. Integer types with exact types, integer, int, small int, tiny int, medium int, and big int. In exact types, the priority is given to precision. Precision means the value before the decimal point. These data types can be signed or unsigned. Now, what is signed and unsigned? In layman terms, signed integer is an integer that can have negative values. That means it will have lower positive range in exchange for more negative values. Whereas unsigned will have positive values with higher range. So if we define signed integer, the allowable range would be something like this. And if unsigned, the allowable range will be from 0 to this number. Well, these are just merely numbers with different storage values. Below are the tables that show the integer types supported by MySQL. Let's try a few practically. Let's create a table. Let's give it a name, DataType _ examples. I'm adding fields to it. Let's give it a name, SID, that is signed integer, and I give data type tiny int. I add one more field, USID, that is unsigned integer, data type tiny int, and select this as unsigned. Now let's save this. Do you want to create more tables? No, not at this point of time. Now let's insert some values to it. To do that, we will write an insert command. Well, at this point of time, no need to worry about queries. We will discuss them in detail in forthcoming lectures. Okay, now, so I'll say insert into data type underscore examples, values. Let's also explicitly define columns to it. We say SID and USID, and in values, let's say -10, -10. Let's try to insert negative values in both the columns and execute. And oops, there is an error, out of range. Why is it so? That's because the USID field is declared as unsigned, so it can have only positive values. Now let's try changing this to a positive number and execute. There we go, it's a success. Let's check the values. I'll say select star from data type examples and execute. And there we have the result. Let's try adding a few more. I'll change the number to maximum capacity for the data type, that is 127 for signed and 255 for unsigned for tiny int. And let's execute, and you see that it is successful. Now what if we try to insert beyond the capacity of the data type? Let's try to insert 128 and 256 respectively. This will throw us out of the range value error. Let's execute, and there you see the error. Now let's try with decimal values for this field. I'll say 127.6. Again, there is an error, and that's because MySQL will internally round off the value and insert. So for a decimal point which is greater than equal to 5 will be considered as one value up. It's a general mathematic rule, therefore 127.6 will be considered as 128. Try changing this 126 to 6 and let's execute. We also need to change the value in USID column. Let's make it 255 again and execute. Here we see that though we have inserted 126.6, the value is stored as 127 because of round off mechanism. And if we change this number to 126.4 and execute, then the value will be 126. Again, the general mathematical rule. Other data types will behave in the same manner, only the difference would be the size as mentioned in the table. Now let's talk about relative questions. So the question is, what are the different numeric data types supported by MySQL? So as we have seen, these are the types which generally you can use for numeric types in different situations. Now let's talk about decimal. This is a fixed type value, that is, this data type will store exact value. These types are used when you need to store exact precision. This is used to handle monetary data such as prices, salary, account balances, etc. The column declaration is usually defined with precision and scale. For example, decimal 5,2. In this example, 5 is the precision and 2 is the scale. The precision represents the number of significant digits that are stored for values, and the scale represents the number of digits that can be stored following the decimal point. For example, decimal 5,2 means that after the decimal there will be 2 digits and the integer part will have 5 minus 2, that is 3 digits, which makes the total length to 5. This will be able to store any value with 5 digits and 2 decimals, so values that can be stored in the above column range from minus 999.99 to 999.99. Default value for decimal is decimal 10,0, that is, if we don't assign any length to decimal, it will take decimal 10,0 as default. Let's check this output practically. I'll add one more field, price, in our table, data type examples, and I give price data type decimal length 5,2. Now changing the field name in insert query to price add the value to 123.345. I'll execute. There you go. The value is stored as 123.35. Again, the same rule applies here for round off. Let's add more number to decimal places. Make it 123.3456 and execute. Still it will round off to the decimal places declared in that data type. Now if I increase the number in precision, let's make it 1231.3456 and execute it, will throw an out of range error. That's because the total length acceptable in the field is 5 with 2 decimal places. So in precision, it can accept only 3 digits, that is 999.99. For anything beyond this value, that is even 0.999, will result in an error. While declaring decimal, if we don't specify any length, then the default would be 10,0. Now let's talk about relative questions. So the question is, how will a decimal type store value if the size given 5,2? Decimal 5,2 means that after the decimal there will be 2 digits and the integer part will have 5 minus 2, that is 3 digits, which makes the total length to 5. This will be able to store any value with 5 digits and 2 decimals. So values that can be stored in the above column range from minus 999.99 to 999.99. Now let's talk about double and float. The float and double types represent approximate numeric data values. MySQL performs rounding when storing values in these. So if you insert, let's say, this value in a float 7,4 column, the approximate result is 999.0001. Doubles are just like floats except for the fact that they are twice as large. This allows for greater accuracy. Let's create some more fields. I'll say F price and it will be float, D price and that will be double. Here precision and scale are optional values for these data types. Let's first empty all the records in the table. So I'll say truncate table data type underscore example. Let's execute this. Now let's execute select query and there it is. It's clean. Now insert some values. I'll say 10.9 in all the fields and execute. So now the result that we have is we have 11 for the price, which is decimal, 10,0 and 10.9 for the double and float column. Let's change the decimal declaration and make it to 5,2. Execute the select statement and there we see we now have 11.00 in decimal. That is the reason we say it a fixed value. Let me truncate the table one more time and insert the values once again. We are doing this because we want to insert the same value in all the fields and see the difference. Let me insert 3 rows, so I will click 3 times on the insert statement. Now execute the select statement and yes, we have 3 records. Then what is the actual difference between these 3 data types? Well, nothing much except for the part that when we do any mathematical functions on it, the precisions are different. In decimal, it will be exact precision with scale, while in float and double, it will be approximate. The difference between float and double is just the storage. Float uses 4 bytes while double 8 bytes. Let's add a sum function to these fields. I'll say sum price, give it a name, decimal price, comma sum F price and name it float price, comma sum D price as double price and execute. There we go. Though the values are the same in all the rows and columns, the results are different. In decimal, we have the exact precision and scale as it should be, while in float we have scale up to 1, 2, 3, 4. Oh, it's a long number. And for double, it's little more precise than float and little less than decimal. Bool, Boolean. These are just the synonyms for tiny int, where 0 refers to false and non-zero values are referred to as true. Say if we execute select false will return 0 and true will return as 1. Now let's talk about relative questions. So the question is, explain the difference between double and float. In decimal we have the exact precision and scale as it should be, while in float we have scale up to 1, 2, 3, 4. In fact, it's a very long number. And for double it's little more precise than float and little less than decimal. The second question is, in which situation you choose the bool or boolean type. So whenever you have a value which represents true or false, then you keep that column as boolean in the database. So here in MySQL we have 3 data types which basically do the same thing. Only difference is in their formats. MySQL has its own mechanism and conventions to manipulate DateTime. That is, basically we enter the date in these types of fields as a string but in a specific format. Let's check this. First we talk about the date data type. This data type stores only the date part of the DateTime. We pass the values in YYMMDD format. You can also use the different separators like slash, dot or hyphen. The next data type is DateTime, and it stores both the part that is date and time. The format is like this. And the third data type is timestamp. Even timestamp stores the same values as DateTime but has a minimum date of 1st January 1970 and the maximum date is 2038 January 19. So what is the difference? Basically, timestamp converts the current time zone to UTC for storage and converts back to the current time zone for retrieval. While the date time is constant, once the data is stored, it remains the same. By default, the time zone is set based on the regional settings of the server or system. As long as the time zone setting remains constant, you get back the same value you store. If you store a timestamp value and then change the time zone and retrieve the value, the retrieved value will be different from the value that you have stored. This occurs because the same time zone was not used for conversion in both directions. Let's check this. Let's alter the table and add few fields in the table. Altering, adding, deleting, all these things we are going to see in the forthcoming sections, but at the moment we are just trying to understand few things, so do not worry if you don't get the alteration of table. I'll create few fields here. Here I am adding created date, it is date type, created time, that I give time, created date time, here I give date time, and created timestamp, and here I give timestamp. Also giving the SID column auto increment. This will automatically insert the record in SID column. So let's save this. Now let's insert some value in it. I'll say insert into data type examples. Let me give the column names, and so all these column names, and I give values. I'm using the now function, the MySQL now function, which gives us the current date and time. So in the 4 fields it should enter current date and time, but because the type is different, let us see how the data is displayed. So let's execute the query. I'll say select SID, created date, created time, created DateTime, created timestamp from the table. And now let's check the table. Now here we have only date in created date column, as this was having date data type. Only time part in created time, and date time and timestamp has both date and time. Let's execute the above query once again so that we have one more record. There we go. Okay, so here we have the value stored in the executed time. Now let's check our current time zone. So I'll say select session.timezone. Okay, so we have plus 5:30, that is IST time zone. Let's add this time zone in the query as well and execute. And let's check the current timestamp column. Let's copy this value and paste it in query editor. And now change the time zone to EST and check. To change the time zone, we will query set session.timezone is equal to -5. Execute select @ twice session.timezone once again to check if the time zone has changed or not. Now we have a different time zone. And now once again execute the select query. Here we can see that current date time value is intact, that is it's the same what it was inserted, but the current timestamp value is different from what it was when we executed insert query. That is, the inserted value in timestamp is getting converted as per the time zone. Alright, so let's talk about relative questions. So the question is, what is the difference between date, date time and timestamp data type? So the date data type stores only date part of date time, whereas date time stores both the date and time in this format. Whereas timestamp stores the same value as date time but has minimum date 1st January 1970 and maximum date 19 January 2038. Also, basically timestamp converts the current time zone to UTC for storage and converts back to current time zone for retrieval, while the date time is constant. Once the data is stored, it remains the same. The second question is, in which format MySQL stores the date data type? So this is the format. Third question is, what will be the query to check the time zone? So to check the time zone, you use select @ 2 times and session.timezone, and this will show you the current time zone. The fourth question is, how can you change the time zone? So you use the set @ 2 times and session.timezone, and you give the time zone. And the last question is, which is the default time zone for MySQL? By default, the time zone is set based on the regional settings of the server or system. Alright, so now in this lecture we discuss about the time. As we can see here, time stores only the time part in hour, minute and seconds format. So MySQL interprets abbreviated time values with colons as time of the day. That is 11:12 means it is 11 hours 12 minutes. But if the values are given without colons, MySQL assumes that the values are the two rightmost values of the time. For example, you might think of 1112 and 1112 as meaning 12 minutes after 11 o'clock, but MySQL interprets them as 11 minutes 12 seconds. Similarly, 12 and 12 are interpreted as 12 seconds. So let's check this out. If I write select cast 1112 as time and execute, we can see the result here. It shows 0 hours 11 minutes and 12 seconds. And as soon as we keep the colons in between 11 and 12 and execute, it will treat this as 11 hours and 12 minutes. Also, let's try to insert date using another conventions, that is using the hyphen, change the now to 2021-09-06, and let's execute. Now let's try with dot. We select and execute, and now run the select query. So here we go. Even though we had entered values using dot, but MySQL converts it to hyphen and stores the value, and also checks the time and date time and timestamp values. They are now stored in the changed time zone format. Now let's talk about relative questions. So the question is, how does MySQL interpret time values? For example, we have 1112, then how will it interpret? MySQL interprets them as 11 minutes and 12 seconds. This is the format. The character and variable character types are declared with a length that indicates the maximum number of characters you want to store. For example, if I say character 30 can hold up to 30 characters. The length of character data type is fixed length, that is, when the values are stored, they are right padded with spaces to the specified length internally. For example, if I say character 5, when storing value AA to this data type, internally it will store value as AA and there will be 3 additional spaces and will truncate the white space while retrieval. Whereas Varchar is variable length strings, that is, it will store the data with spaces. Below table shows how the values are stored. So you can see that if there is no value given, then in variable character it will not occupy any space, whereas in character it will still have the 4 spaces. That's the advantage of taking variable character, but you can decide depending on the requirement. If you see that there is a fixed number of characters always to be inserted, certainly character is also a useful type. Let's try this with a small example. We are going to add 2 columns in our data type example database. One is pin code with character length 7 and zip code with variable character length 7. Okay, let's save this and insert one record. So I'll say insert into table name, pin code and zip code, and values 1, 2, 3 and 3 spaces, and same value for zip code as well. Also, let's keep the select query ready. So I'll say select pin code, zip code from data type examples. Select both the query and execute. Okay, here is the result. Also, let's check the length of the values that has been stored. So we add length column name, that is pin code, and length zip code. Let's select and execute. Here we can see that the length of the pin code is shown as 3, though we had added 3 spaces in it. But as per the MySQL rule, character trims the trailing white spaces while retrieval, but internally it occupies the full length of 5 characters, and on the other hand, length for the zip code is as it is what we have entered. Now let's talk about relative questions. So the question is, what is the difference between character and variable character, that is char and varchar? So as we discussed earlier, the length of character data type is fixed length, that is, when the values are stored, they are right padded with spaces to the specified length internally. For example, if I say character 5, when storing value AA to this data type, internally it will store value as AA and there will be 3 additional spaces and will truncate the white space while retrieval. Whereas varchar is variable length strings, that is, it will store the data with spaces. Below table shows how the values are stored. So you can see that if there is no value given, then in variable character it will not occupy any space, whereas in character it will still have the 4 spaces. That's the advantage of taking variable character, but you can decide depending on the requirement. If you see that there is a fixed number of characters always to be inserted, certainly character is also a useful type. A blob can hold a variable amount of data and are used to store large amounts of binary data such as images or other types of files. Fields defined as text also hold large amounts of data. You do not have to specify any length with these data types. The difference between both of them is that blob values are treated as binary strings and text values will be treated as character strings. Let's add few more columns. Essay, give it a type text. Add image and give it a type blob. Insert a record, change the column name to essay, and in values between these single quotes, let's add an HTML element and some long text and symbols. Add select query and execute both the queries. Here is the result. We can see that beside the column there is button with the size of the column. This is actually the size of the data that we have entered. We click on it and we can see the data that is entered. Same goes for blob as well. Change the column name in the query and add few more lines in it and execute. So now here we can see that the size of the column has increased because we added one more line in it. Well, the behavior of both these data types are similar, only internally they are treated differently. Blob is treated as binary while text as character. Now let's talk about relative questions. What is the purpose of blob data type? A blob can hold a variable amount of data and are used to store large amounts of binary data such as images or other types of files. The second question is, what is the difference between blob and text data type? Well, the behavior of both these data types are similar, only internally they are treated differently. Blob is treated as binary while text as character. Enum is an enumeration type where you define fixed values to the column. For example, let's add a priority field with enum data type. As soon as we enter the data type as enum, it will ask us for a set of values to enter. Let's add low, medium and high. Let's insert a record now. In this query, change the column name to priority and in values, let's add number 1. Also change the column name to priority in the select query. Let's select and execute. Now in result we can see that value is displayed as low. That's because behind the scenes MySQL manipulates the strings and encodes it in index numbers starting from 1. That is, low will be considered as 1, medium will be 2 and so on. This depends on the order of the columns that we have entered. Even we can enter the data using a string like we are doing here. Changing the value to high will also result in a successful insert. Even while we select a query, we can search the record either by string like select priority from data type examples where priority is equal to high. Let's execute this and yes, we have the result. Or even by the index number, let's change the value high to 1 and execute and yes, here is the same result. So now let's talk about relative questions. explain the data type enum. Enum is basically an enumeration. You already know if you have some exposure to programming, then enumeration is basically the labels, and there is also an internal numbering system. Every label is given a number also, so you can either refer to the number or the label depending on the requirement. Now that we are familiar with database and data types, it's time to create an actual table wherein we can store some information. Before we jump into creating tables, let us know a few things about database storage engines. So what is a database storage engine? This itself is one more question. Well, it's a MySQL component that internally manages the SQL operations performed on different table types. Though we have few different types of storage engines, InnoDB is the default and mostly used storage engine. Prior to MySQL version 5.5, MyISAM was the default storage engine. The main difference between InnoDB and MyISAM is with respect to designing a table or database. That is, they are supported for referential integrity and transactions. That is, if we need the database to support transactions, that is, changes made by multiple operations handled as a single unit of work, with all of the changes either applied or all the changes reverted, then we should choose the InnoDB engine, since these features are absent from the MyISAM engine. The other big difference is concurrency. With MyISAM, the DML statement will obtain an exclusive lock on the table, and while that lock is applied, no other session can perform a select or a DML operation on that table. While InnoDB has a row locking system rather than table locking. So if your application uses tables that are never or rarely modified, you can safely change their storage engine to MyISAM. Well, there are other storage engines available in MySQL with different design goals, but let's not get into those details, as in real case scenarios, use of these engines are negligible. Just to check what other storage engines are available, we have show engines command, and here you get the list of engines available. This topic itself is little advanced for the initial learner of MySQL, but I have kept this here so that you can keep these terms in your mind. You can certainly explore more when you develop yourself in MySQL. Now, if we talk about the relative questions, I already mentioned one question earlier. The second question is, what is the difference between InnoDB and MyISAM? That also we have just discussed, and these are the points. The main difference between InnoDB and MyISAM is with respect to designing a table or database. That is, they are supported for referential integrity and transactions. The other big difference is concurrency. With MyISAM, the DML statement will obtain an exclusive lock on the table, and while that lock is applied, no other session can perform a select or a DML operation on that table. While InnoDB has a row locking system rather than table locking. Now let's jump into creating a table. Let's first create a new database. We already have learned how to create a database in our previous lectures. So let's create one. We will name it as nj_sampledb. I'll just execute, and we have the database now. So I'll say use the database name and execute. So this command will set the working database to the nj_sampledb. That is, now any query that we execute will refer to this particular database. The syntax to create a table is create table name. We give the column name and we also specify the column data type and column definition. So now let's create one. I'll say create table product category, and the fields that we have to define will be between these parentheses. Let's say ID. This is a standard practice that is followed by the developers community, that every table will have a primary key, that is, this column will not have a duplicate value and also will not contain null value. That means there has to be some unique value. So we say ID data type, we will give it as integer and also give it a column definition, auto increment. So here auto increment means MySQL will automatically insert the data in this field in sequential manner. Let's give few more columns. I'll say category name, and here I'll define it as character, that is, and length will be 20. We are giving this length because we think that this will not have more than 20 characters, and let's say this field will not be null. So I'll say not null. Null means no data. No data means no data. We need to understand that this is different from 0 in numeric types and empty string in string types. That means a record without this field cannot be inserted into the table. It's a mandatory field. Few more columns. Category title. This I'm going to define Varchar, not null. Description, say Varchar 150. Here we won't give anything in definition as we don't want any restrictions on it. And also give one more, created on. Let's give this as timestamp, and default will be now, or we can write current timestamp. I generally prefer now as we have less characters to type. And lastly, we create a primary key column ID. Okay, now let's select this and execute. There we go. The query is executed successfully. Now let's execute show tables. And now we can see the table that we created in the table list. If we want to check the details of the table, we can do that using DESC, or describe table name. So that is, I'll say DESC product category or describe product category. This will show us the details of the tables. Now if we want to get the create table statement, we will write show create table product category. This will give us the create statement of the table. Let's try to insert few records. To insert the records in table, the basic query is insert into table name values, and in parentheses we will have the values. So let's do it. Insert into product category values. Now here, because we are not explicitly defining any columns, we will have to pass the values equivalent to columns. That is, all the field values must be passed. So the first column is if we pass 1. Next is category name, so we will pass the values between single quotes, let's say mobile. This is basic thumb rule for any database, that the values must be passed in single quotes except all numeric data types. That is, any int, double, decimal, boolean must be passed without quotes. Okay, let's move to next value, that is category title. Let's try to pass null value. Next is description field, write some description. And last is our date field, we will pass now function. Let's try to insert this and check. This should give us error because we have passed null in category title, to which we have given a table definition on not null. That is, it is mandatory to pass value in this field. Execute, and there we see it says category title cannot be null. Let us also write the select statement along with it. I'll say select star from product category. Now let's give some value to the category title field and try. And there we are, the record is inserted now. So what is the use of auto increment here in the ID field? Well, auto increment means it will insert the value automatically in that column in a sequential manner, even if the column is not specified in the insert statement. Let's say I write insert into product category, category name, comma, category title, comma, description, comma, created on, and values, some name, some title, blank description, and now the function. Let me select and execute this, and there we go. You can see that even though we have not given value to ID, it has automatically inserted the record with an incremented value following the last record. Same applies for created on column because we have given default value to it. This will also automatically insert the value mentioned in default. Let's just remove the created on column in column name and values. Select and execute, and we can see the result. Created on column has the date time inserted. Well, nowadays we don't have to worry about remembering the statements as there are options available with GUIs. But it is good to have the concept clear by writing the queries, as GUI may vary from tools to tools, but the statement will always remain the same. Okay, now let's talk about the relative questions. So what is the use of auto increment here in the ID field? Well, auto increment means it will insert the value automatically in that column in a sequential manner, even if the column is not specified in the insert statement. So what is null and not null? So basically, when you say null, that means null values are allowed in the field. When you say not null, it means that you cannot skip that field. One has to enter value in that field. What is the purpose of default column? So when you set a column with default value, so in case if you do not enter, let's say you do not specify the column name, it will automatically insert that default value. The next question is, what is the primary key? If you define a column as primary key column, it means the database will put a check on that column, that is the field. It will automatically make sure that there has to be a unique value entered and it cannot be a null value. Now, what is foreign key? Why do we need it when we have the option of creating an n number of tables and columns in it? Though we have the maximum limit for columns in a table, but then that is way beyond the actual need. If I remember correctly, around 4000, but forget it as it is never needed. But let's come to the point. What is the need of foreign keys? Of course, because we don't want data redundancy, that is the reason we are using RDBMS. We don't want the same data to be entered in every table. Let's take very common example of e-commerce, where we have customer with their orders. Here we already have a customer table with us, so there is no point in including the customer details in the order table. Instead, we would rather use the reference of customer table in our order table. And that customer ID in order table, which is the primary key of customer table, is referred as foreign key. Now say for example, if a phone number of a customer changes, we don't have to worry about updating the record in multiple tables. We just have to update the record in only one table. Now when we join both the tables, we have the order details with full customer information as well. And the main purpose of foreign keys is referential integrity. That is the relationship between tables. Foreign key is used to establish the relationship between tables. Generally, what happens is tables can form a hierarchy of relationships in such a way that if a record from one table is updated or deleted, it destroys the meaning of another record in the table. In this diagram, we can see the customer ID is referenced in order table and address table. Now suppose we update this customer ID or delete this record. The records with this ID in other tables will be useless. Their identity will be destroyed. For example, if we delete customer 101 from customer table, the record with that customer ID will have no meaning. That also means that referential integrity is the logical dependency of foreign keys on primary keys. By default, MySQL server, rather it is any database server, does not allow us to violate referential integrity. However, we can explicitly define different cascade options in onUpdate and onDelete. That means cascade option will execute whenever update and delete operation is performed on primary key tables. Cascade is when a primary key record is deleted. It will delete the child records. It will delete the respective records. What is a foreign key, and explain the referential integrity as well. Foreign key is used to establish the relationship between tables. And the main purpose of foreign keys is referential integrity. That is the relationship between tables. Referential integrity is the logical dependency of foreign keys on primary keys. The next question is, what is cascade option? Cascade is when a primary key record is deleted. It will delete the child records. It will delete the respective records. Now that we have gone through the foreign key concept, let's try it practically. The basic syntax to create a table with foreign key is like this. In this syntax, the first option is a constraint name after the constraint keyword. If we omit this, MySQL will automatically create a name for it. In the next line after foreign key, we have to specify the foreign key name with the column name in the table that we want to reference. Third option is references of parent table, that is which is the parent table and column of this foreign key that we define here. And finally the options, that is cascade, restrict or set null. If we don't specify this option, default action will be restrict. Let's jump into creating a table. In our previous lecture, we have created nj_sampledb database and also have created a table named product category. Now let's create a table named product with category ID as a foreign key. Okay, let's start creating. We already know the syntax of creating a table. Let me open a new query window first. I'll say create table product. Let's give the column name, product ID, which will be int, not null, and auto increment. Next we create product name, type Varchar, length 30 and not null. Then I create category ID, type int, and also created on data type timestamp and default value to now. Define primary key for this table, product ID. Now we give our constraint name, say constraint fk, that is foreign key, underscore name of the column on which we are creating foreign key, that is the category ID. Next is foreign key and then columns in parentheses, that is category ID, and then we have references and then parent table name, that is product category, and column name of parent table that we are going to refer, that is ID in parentheses. Let's execute this. Okay, table has been created now. Let's refresh the database browser. Now let's insert some data in the products table. Insert into products product name, category ID. I have already explained the basic insert in our create table lecture, so I am not repeating the same again. We will have a lecture for this further which will elaborate what insert statement is and how does it work with different options. Okay, let's move forward. Values, I'll say Samsung, and let's keep the category ID as some random number. Let's say 10. Now actually we don't have a record with ID 10 in product category table. Let's make a select query here. I'll say select star from product category and execute. Okay, so here we have records with ID 1, 2 and 3. Let's execute this insert statement and check. This will give us a reference error. There we have an error. It says cannot add or update a child row. That's because MySQL is trying to search a record with ID 10 in product category because we have referenced it to product category. Okay, now let's insert a few valid records. So I will change the category value to 1. Let's copy this insert statement and paste it few times and change values to Apple, Nokia, MacBook, and category ID to 2, and the last one Surface and 2. Let's select this and execute. Now let's execute select for product table and also for product category as well. So I'll say select star from product category and select star from products. Selecting both these queries and executing. Okay, so here we can see the records now. Now let's try to delete the record from the parent category and check. So we will execute delete from table name product category where ID is equal to 1. So here it gives an error because the default action is to restrict, because the ID that we try to delete is having the reference in the product table. This will go with the update as well. Let's try it. I'll say update table name product category, set ID is equal to 10 where ID is equal to 1, and I execute. And yes, we have the error here, that is foreign key constraint is working as expected. Now let's change the reference option and try. To do so, we have to alter our table, and MySQL does not provide any direct option to alter the foreign key. So we have to delete and recreate it. Let's begin. I'll say alter table products and drop foreign key name that we had given during table creation, that is fk_category ID. Alternate, you can check the show create table statement and check the key name, and then we recreate it using alter table products add, and after the add the constraint remains the same as we used during create, that is constraint fk_category ID, foreign key category ID, references product category ID, and after this we will add on update set null and on delete set null. Select and execute, and there we go. Now quickly check the record in our table. Let's execute both the queries, and yes, we have the records. Now let's try to execute update statement. Select the update statement and execute. Now it says that the query has executed successfully. But what is the implication of it? Let us check that. Execute the select queries. So now in product category table we see that the record with ID 1 has been updated with ID 10, and in the products table the records whose category ID was 1 is now set to null. Same goes for delete. Let's delete the category with ID 2. Delete from table name category where ID is equal to 2 and execute. Okay, the query has been executed successfully. Let's check the table. Execute select query and check here. We can see that there is no record in the product category with ID 2. That's because the record is deleted now, and in the products table the records with category ID 2 has been set to null. And lastly, let's check one more option, that is cascade. The alter statement will remain the same. The purpose of alter statement is to change the structure of the table. So here we just have to change the set null value to cascade in both the options, that is on update cascade and on delete cascade. Let's execute both the queries, that is drop foreign key and add foreign key. There we are. Let us also truncate both the tables and insert some fresh data again. So we have truncate table product category and truncate table products. So now you see that we have an error. Truncate product category is throwing an error. That is because it has been referenced by product table. This is an additional integrity check by MySQL that even if the child table is empty, it will not allow us to truncate parent table records. But to override this, we have a property foreign key checks. So now let's set this property to 0 and execute it. Great. Now set the foreign key check value to 1 again. Let's not mess with the default properties unless necessary or if we have any special case. Now both the tables are empty. Let me insert some records in both the tables. There we go. Let's see the cascade option in action now. Let's try the update statement first. We update the category ID to 10 from 1. Select and execute. Again, it's a success here. Let's check the tables. Okay, so here we can see that the record is updated with the ID that we have provided, and now let's check the product table. And here we see that the child records are also updated with the parent ID. That is, the category ID is automatically updated to 10 where the previous ID was 1. And now let's try to delete category ID 2. Execute the delete statement, and yes, the query is executed. Let's check the table once again. Execute select statements. And oops, the record is deleted from product category table. And what about product table? Yes, that's correct. The records from the product table are also deleted with category ID 2. So this is how we can play with various options of foreign key. Now let's talk about relative questions. How can you add or remove foreign key constraint at a later stage? Now once that we have created a table and then we realized that the table needs some modification. So what do we do and how? Do we need to drop the table, that is delete the table and recreate the table? If yes, then what about the data that exists? Well, fortunately we are blessed by MySQL, that is actually the SQL queries, to have an alter table option. So what modifications can we do with this command? We can add columns to table, change the data type of an existing column, rename column, change column position, that is reorder columns, delete column and rename table as well. Well, we have different commands to fulfill all these modifications which we need to use with alter table command. Let's discuss them one by one. The first one is add keyword, which is used to add one or more columns to the table. In this syntax, after the alter table, of course, we have to provide the table name to which we want to add column or columns, followed by add keyword, then is the new column name, where we will specify the name of the column that we want to add, and then column definition, that is data type of column, and then is the order, first, pipe after, column name, that is where this column needs to be added. Let's check an example. We are in nj_sampledb. We have already created a table named products in our previous lectures. Let's focus on that table. We will first check the existing definition of the table using describe products. It is always a good practice to check the existing definition of the table before we make any changes to it. Okay, so here we have our definition. Now let's add one column to this table. Let's begin. We will write alter table, table name, that is products, add column name, let this be product image, and data type blob. Now let's select and execute both the statements, and now we can see that the product image has been added as the last column. That's because we have not provided the order for the column, so by default it will add it as the last column on the table. Let's try to add few more columns with ordering sequence. Let's add price column to the table, change the data type to decimal 7,2, and we want this as the first column, so we write first. Add one more column, selling price. We keep it as decimal 8,2, and we want this column to appear after category ID. Again, select both the statements and execute. And there we see price is placed as the first column, and we have the selling price appearing after category ID. Next option that we have is modify, which is used to change the column definition, that is data type of the column. Syntax for this is very similar to add columns, except that add is replaced with modify keyword. Rest all definitions remain the same. Let's say if we want to change the definition of price column, so in this syntax we just change this add keyword to modify and change the new data type that we wanted. Let's make it to 10,2 and also reorder this column to appear after selling price. Let's also change the order of created on column, so we write one more time modify created on timestamp default now. This definition has to remain same in case we just want to change the order, and then we reorder this and move it after product image. Let me put a comma here because we are writing multiple modify commands. Once again, select both the statements and execute. And there we are with the result. Now we have price after the selling price with changed data. Type definition and also created on column has moved below product image. Let's talk about the relative questions. How will you add a column in the existing table? So this is how you do it. Next option in the list is change, which does all the functions that modify does, and on top of that it can also rename the column. So syntax to do so is alter table, table name, then you have change the original name, where original name is the current name of the column in the table, and the new name is the name that we want to give to that column. Let's say, for example, we want to change the column name price to product price. So now this statement, we change this modify keyword with change, and after the column name, that is after price, we add new column name product price, and also change the position as well and place it after category ID. Select and execute. and there we are. Next option that we have is drop, which is used to delete the column from the table and also the easiest among all. Let's say if we want to delete product image from our table, just write drop product image, select and execute. Successful. Oh, we missed to select the describe statement. Never mind, it's not too late to select and execute it again. And here we go, no product image column in the list. We can also rename the table using alter table command. Let's say we want to rename this table. We write rename followed by a new table name. Let's say products. So products underscore table. Select and execute. There we go. Now execute the describe statement. Oops, now it says table doesn't exist. Why? Because now the table name has been changed. So now it's describe products underscore table instead of products. Select and execute, and there we go. Okay, now let me change the table name back to what it was. Now let's talk about relative questions. So what is the difference between change and modify? And the same question can also be asked as in which scenarios you will use change or modify. So change has the additional ability to change the column along with all the functions that modify can do. So if we want to rename the column in the table, we will use change instead of modify. Is it possible to rename a field name or a column name? Yes, of course it is, and this is the syntax. Now, how do we insert data in the table? So we have an insert statement to add new records to the table. Well, we already have seen a glimpse of it in our previous lectures. The basic syntax for insert statement is like this. In this syntax, after the insert into clause, we have table name, that is the name of the table in which we want to add a record, followed by the list of columns inside the parentheses, and then we have values followed by the actual values which are again in parentheses. Here column names are optional. If we don't specify the column names, then we have to provide values for all the columns in the table. Let's check it in action. So we will select the njSampleDB in which we have a product category table. Let's check the table definition first. I'm sure that you guys know now how to do it. So I'll say DESC product category. Okay, so here we can see that we have an ID column which is the primary key with auto increment. Then we have category name which is not null, then category title again not null, followed by description which allows null, and lastly we have created on with default values as current timestamp. So now let's write a query to insert records in the product category table. I'll say insert into product category values. Now here we are not explicitly defining the columns in which we want to insert the data. That means the values that we are going to pass here has to be in sequence as per the table definition. So first we have an ID column which is auto increment and primary key. Now we already know that primary key means this column will have a unique value, and also this is auto increment, that means it will automatically insert value in sequential manner. So instead of giving any explicit value in it, we will let MySQL do the action as per the definition. That is, auto increment value will be used. comma, then we have category name, and this is not null. So in this we give some value inside a single quote. We have already discussed this before as well, that any data type other than numeric data type has to be written in single quotes. Alright, let us add values for the other columns as well. Next is category title, which is again not null, so we give some value here as well. Next we have description, which says null value yes, so either we can give some value to it, or even here we can write default, and then we have created on, which is timestamp with default value. So again here we write default. Close the parentheses and execute this query. Okay, so here it says one row affected. Let's do a select query and execute. Here we can see our inserted records. Now in the above query we can see that actually we have provided values only for two columns, that is category name and category title. Rest all values are default, so why to write all the columns? So now let's add the column names here, in which we want to pass the values, that is in parentheses we will write category name comma category title. Now in that case, even here in values we don't need this default values, so let's remove it. So there we are, one row affected. Let's check the table now. When passing columns explicitly, sequence doesn't matter. We can change the order of the columns. Of course, you also have to change the order of values as well. Now let's talk about bulk insert. So we have seen that we can insert records using insert into clause. But what if we need to insert bulk records in the table? So we need to write multiple insert queries, is it? Well, in that case, you just simply have to put a comma after the first bunch of values and add the new values in parentheses, as we are doing here. We can add as many values as we want. So here I have added 4 records. Let's execute and we can see that it says 4 rows affected. That means 4 new rows are added in the table. Let's check using a select query and you see the result. So the relative question here is, how do you insert values in a table? So this is how you insert. Is it necessary to give column names with the insert statement? Absolutely not. If you need to specify columns in specific sequence, then only you give the column names in the insert. Otherwise, you simply avoid column names and say values and start writing the values in the parentheses, and that should add records in the original sequence of the table. But if you want to change the sequence or you want to add specific columns only, then you have to specify column names with the insert query. Insert ignore into and insert on duplicate key update are MySQL's extension over the standard insert statement. Now suppose we try to enter the value in the primary key with the value that already exists in the table. MySQL will throw us an error. To overcome such a situation, we have insert ignore into clause. Let's check this example. Let's first try to insert a valid record. The last record has ID 10, so let's give the ID as 11 and give category name as new category and category title as ignore test. Let's execute and this is working as expected. Let's check the records. Execute the select statement and there we are. The record with ID 11. Now let's try to execute the same insert query here. Now it throws an error duplicate entry 11 for key, because we are trying to insert the ID which is already present in the column, and again that's because ID is a primary key. Now to avoid this error, we have to add ignore keyword after the insert clause, and we are done. Now execute this query again. Now you can see that it is not returning an error. Instead, it shows a warning with 0 rows affected. We can check the warning using show warnings. And now if we try to insert a valid record by changing the ID, then the same statement will work as a standard insert statement. Execute it and we can see that now it says 1 row affected. We also have an onDuplicateKeyUpdate clause, which updates the value if any primary key constraints fail. That is, if any duplicate key is found, it will update the column provided in onDuplicateKeyUpdate clause. For example, in this same statement, if we remove the ignore keyword and right after the standard insert statement, we add onDuplicateKeyUpdate, and after that we provide the column name with value that we want to update. Let's say category name is equal to updated category. So here this statement will first try to insert the record, and if the insert fails because of primary key constraint, it will update the given column by the value for the primary key. So in this case, it will update new category to updated category for ID 12. If the value is inserted, it will return 1 row affected, but if the record is updated, then it will return 2 rows affected. Select the query and execute, and here it says 2 rows affected because the record is updated. Let's execute the select query and check. There you go. Now let's change the ID value and execute, and it will be executed as a standard insert statement. Execute this now, it says 1 row affected. So this is just an extension of MySQL. However, using both these statements is not a good practice and not advisable to use it unless for a specific case, because based on error, if we want to advise the user something, we won't be able to do that, as it just produces the warning, and in enterprise level application we cannot just ignore or update the columns just based on some assumptions and benefit of doubts. Let's talk about relative questions. The question is, how do we update the column value using insert statements? So it's the onDuplicate key, and this is how we use it. So far we have learned how to insert data into a single table. But what if we want to insert data into multiple tables? Let me give you a pretty simple and good example. And that example is an order cart where you have multiple items in one order. So here comes in action the parent-child relation table, where orders table is the parent table with customer and order ID information, and then we have order details table with the product details with reference to the parent order ID. Let's quickly check this orders table where we have order ID, customer ID, order date and address ID. So we have all the customer details here, but we don't have the actual products for this order. They are here in the order underscore details table. Here you can see that we have 5 columns, the ID column, then we have order ID, which is the reference of ID column from orders table, so that we know that the order items is for what order ID. Then we have product ID, quantity and price. So here one order can have one or more items in order details, and this is what is called parent-child relation. So now let's check how to insert data into multiple tables. Let's quickly insert the data in the orders table. So insert into orders, values, because we have fewer columns, so let's not define an explicit column. We just write values and default because it's an auto increment followed by 1, now, 1. We already have learned in detail about insert and what values to use and when in our previous lecture. So let's execute this. Great. Now let's check our order details table. Here we have an order ID column. Now here comes the tricky part. In this order ID column, we need to insert the order ID which is generated by MySQL when we had executed the insert statement in the orders table. Therefore, somehow we need a way to retrieve the ID that was lastly inserted. Well, to do that, we have a built-in MySQL function last_insert_id which will return us the ID of the last inserted row. Let's check this. I'll say select last_insert_id to execute this. We'll put a parenthesis after it and execute. Yes, so here it is. Now to insert this record in order details table, we will use this ID as order ID, and to do this we will write insert into order details values default, and then in order ID column here we will use this last insert ID function and then some more values. Product ID 1, quantity 2, and price, let's say 10. Let's copy paste this one more time and change the product ID, quantity, and price values. Select and execute. That's good. Now let's execute the select statement on orders table. I'll say select star from order_details, and there we go. Here you can see the value in order ID. It is the same value that was last inserted in the orders table. What is the purpose of last_insert_id function in MySQL? Last insert ID helps us in retrieving the ID that was lastly inserted. It is a built-in MySQL function which will return us the ID of the last inserted row. Alright, so now we will learn how to update a record in the table. Well, update statement allows you to change values in one or more columns of a single or multiple rows. So in this syntax we have to give the name of the table followed by update keyword. Next we have to give the column name with the value in set clause. We can give multiple columns followed by comma, and next is the where clause where we will specify which row to update. The where clause is optional here, so if we don't specify where clause, MySQL will update all the records in the table. However, this is a very important clause and should not be omitted because most of the time update is used to update a particular record rather than the whole table. Let's execute a select query on our products table and check. Now here we can see that we don't have any values in product price and selling price column. Now let's assume that we have got the prices for the products, so now we should update the product prices in the table. So let's write an update query. Update which table? So products table. Next we add set clause, and this is where we will specify new values for column or columns. In our case we are updating product price to 10, selling price, let's say we make it 12, and then we write the condition. With this condition we will identify which record we want to update. Let's say we want to update the product with ID 1, so we write product ID equals to 1. Let's execute this, and there we go. Let's get back to the table, and here we see that the product price is updated to 10 and also selling price to 12. Good. Now let's go ahead and update one more record. Let's assume that we want to update the selling price by adding 20% in product price. So instead of writing a literal in the value like some number, we can actually write an expression. So let's keep the product price to 13, and here selling price instead of value we will write product price plus product price into 0.2, that is, it will add 20% of the product price in product price and update the value. So this is how we deal with the update statement. Now let's talk about relative questions. So the question is, how will you update values of column? So you use the update statement with this syntax. The second question is, what happens if you do not use the where clause? So if you do not specify the where clause, whatever update statement you have given, it is applied to the entire table. The third question is it possible to give expressions with the update statement instead of fixed values or literal values? Certainly it is, like we have done here. We have updated the product price with 20%. So this is how you apply the expressions instead of fixed values. So now we have learned how to update a single record. Now let's see how we update multiple records. Is it that hard to do? Well, it's not so. Only the condition that we give in where clause has to be more generic, and rest everything remains the same. Let's check this products table. Say for example, if you want to update the category ID of all the products whose category ID is 10. So our update statement would be update products set category ID is equal to 1 where. Now here we will write more generic condition like where category ID is equal to 10. So this will update all the products with category ID 10. Let's execute this, and there we go. Now let's execute the select statement and check the data. We can also use the in operator in where clause to update multiple records. For example, if we want to update product price whose category ID is 3 or 4, then we will have to change the where condition from is equal to in, and in parentheses we will write the IDs to update. Here it will be 3, 4. Let's also change the column from category ID to product price and set the value to 100. Execute this, and there we are. As I have said earlier, that where clause is optional, so if we omit it, all the records in the table will be updated. Let's see, we remove the where condition from here and change the column to selling price value be 1000. Execute, and the product price are gone too high. Now let's talk about relative questions. So the question is, instead of or, how will you use the in operator? So this is how you use it. You use the in operator and you can give list of values. So this will be in a way the or condition. So if either of the condition is satisfied, then that result is returned. In this lecture, we are going to learn how to retrieve data from a table. To do that, we have a select clause. The basic syntax for select is select star or asterisk from table name. This is the very simplest select statement which will fetch all the records from the given table. Instead of a star, we can also provide column names from the table. Let's check this with some examples. Here we are going to use the sample database SQLYog that is installed with MySQL. So let's first select the database. Alternatively, we can also write use SQLYog. Okay, so here we can use the list of tables in the database. We will now query on the customer table to fetch the record. Let's start with the simplest one, that is select star from customer and semicolon. Semicolon means that it is the end of the query. This is important when executing multiple queries. Also, MySQL is not case sensitive, so instead of writing select in caps, we can also write select in lowercase. But it's good to write the keywords and clause in caps and other things in lowercase. Let's execute this, and there we go. We have all the customers from the customer table. Instead of retrieving all the columns, we can also retrieve specific column by giving column names after the select clause, like select first underscore name, comma, last underscore name, comma, email from customer. Execute, and here we can see that now we have only 3 columns returned in the result set. And yes, one more thing, it is not at all necessary to provide column names in sequence as it is in the table. We can keep email first, then first name, and then last name, so the sequence of columns doesn't matter. Well, writing select queries with column names is very good practice, because when we have a big table, many columns, and perhaps with millions of records, and if we are using asterisk, it is going to consume a lot of memory on MySQL server as well as on the network. So it's always good to write only the columns that are needed. Now in this select statement, we have 2 clauses, the select clause and the from clause, but it is totally optional to use from clause, as select clause can also be executed independently. So let me remove this from clause, or instead let me comment this out by adding 2 hyphen before the from clause. Comment means it will tell MySQL not to consider this line in the execution in the statement, which means that line will be omitted. And instead of providing any table name, we can put some values, like between single quotes we write some value, comma 1, or even any arithmetic expression, say 10 plus 10, and execute, and we get the result something like this. Now let's talk about relative questions. So the first question is, what is the use of select clause? So of course it is there to fetch the data, that is retrieve the data. You can also apply the expression, like here we tried 10 plus 10. In any development with database, you generally see that select statement is extensively used, so you should have good hands-on with the select statement, the select clause. Second question, what is the meaning of the asterisk, that is the star? So it means basically you are trying to fetch all the columns. Is it the good practice to have all the columns all the times? Of course not. As I mentioned earlier, whenever you need to refer specific columns, better to specify the column names rather than giving the asterisk all the time. In this lecture, we are going to learn how to sort data in the result set. Now when we execute a select statement to fetch data from the table, the result set that is retrieved is unspecified, that is, it is displayed as it was stored in the table. Now if you want to sort the result, we have to add an order by clause in the select statement. This is the basic syntax of how we are going to use order by. We can either choose to sort the result in ascending or descending order, followed by column name. ASC here stands for ascending and DESC for descending. By default, the order by clause will sort the result in ascending order. That means you don't need to specify ASC if you want to get the result in ascending order. Let's check this example. Here we have already selected the Sakila database. Let's query select statement on the actor table. I'll say select first name, comma, last name from actor. So here is our result. We can see that the list is coming in an unspecified order. Now let's add an order by clause and sort the data by first name. So we add here after the from clause order by first name. This is going to sort the result by first name in ascending order. Let's execute this, and here we can see now the result is sorted on first name in ascending alphabetical order. Now if we write ASC after the column, it will give us the same result because the default action of order by is ascending. Now let's try sorting the first name in descending order. To do so, we just have to add DESC after the column name in the order by clause. Execute it. And now we can see that the result is sorted by first name but in descending order. Let's add even the last name in order by. So we add comma last name. So this will sort the result by first name in descending order first, and then we'll sort the sorted result of last name in ascending order. Let's see if we can see any visual changes in this set of data. Okay, let's focus on this Warren data. Right now we can see that last name is not in ascending order. So once we execute this query, the last name should get sorted in ascending order. Execute this, and yes, there we can see that the last name is sorted in ascending order now. Now we can keep playing around sorting the data in ascending and descending order. Oh yes, and it's not that we can only sort by the columns that are present in the select statement. Even if we remove first name, for example, from the select list, even then we can sort the result by first name because it exists in the table. It's not about you specify it in the select statement, then only it's going to sort it. So let's say if I remove this first name from the select list, I can still sort data by first name in the order by clause. Alright, so now let's talk about few relative questions. The first question is, what is the use of the order by clause, or how do you sort the data while fetching it? So it's about the order by clause. You have to put it at the end of the query and you get the result in sorted order. The next question is, what is the default order of order by when you fetch the data? So it is the ascending. So if you give just order by, it's going to fetch the data in ascending order. How will you fetch the data in descending order then? So the DESC keyword, the DESC modifier, is going to be used when you have to fetch the data in descending order. The next question is, when you give multiple columns to sort, how does it implement the sorting? So naturally, when you have more than one column, first column is the main priority. That column data is sorted first, and then the second or the subsequent columns are sorted. What is where clause? We have to use the where clause when we need to filter data. That is, where clause allows us to specify a search condition for the result set that is returned by a query. This is the basic syntax of how we write the where clause. Select the list of columns or maybe star from table name, then you give the where clause and you have the search condition. We can also combine search conditions with one or more expressions using the logical operators like and, or, in, etc. When using where condition, the operation will be performed only on the row that satisfies the search condition. Besides the select statement, where clause is also used in update and delete statements to specify the row that needs to be updated or deleted. We have already seen the where clause in some of our previous lectures, but now we are going to learn them in detail in upcoming lectures. In this lecture, we will learn how to use the where condition with an equality operator. In the equality operator, MySQL performs an equality comparison. That means it will check if the value is, for example, 1 equals to 1. To use the equality operator, we have to use single equal to sign. Why am I saying single? The reason is if you have any programming background like C, C++, Java, C#, you see that when there is a comparison, that is equality, then we use double equal to. But here single equal to is just to compare a value. Single equal to in other languages refers to the assignment operator, but in case of SQL it is the single equal to which is going to compare the equality. Let's say for example, if you want to find the records with customer ID 1, the statement will be select star from table name where the column name, that is customer ID in this case, is equal to 1. Let's check this. Let's find the customer with ID 10 from the customer table. So to do that, we will write select star from table name, that is customer, then we will write where clause, where, then the column name, in our case it will be customer ID, then next comes the operator, that is equals sign, and then the record we want to find, that is 10. Execute, and here we can see that we have only the record with customer ID 10. Well, we can use equality with most of the other data types as well. Like if we want to search a record where the first name is Sarah, then we will write select star from customer where first name is equal to Sarah between the single quotes. We have already learned this in our previous lectures that any string data type has to be returned between single or double quotes. So let's execute and check the result. So here we have it. So this is the basic idea about equality operator. Now let's talk about the relative questions. The first question is what is the equality comparison? So we use the equal to sign to compare. Equality looks something like this where we have 1 equal to 1. The second question is with which data types can equality operator be used? Well, it can be used with string, date, time, number operators. So there is no limitation. As long as you have something to compare, that is the equality, you can use this operator. In this lecture, we will learn a few more operators used in where condition. These are the operators other than equal operator that are used in where clause, like greater than, equal to, smaller than, equal to, and not equal to. Typically, other than not equal to, all these operators are used with number or date time types. Let's go through it one by one. First, we have greater than. Let's say for example, if we want to find the customers with ID greater than 500, then we use the greater than operator. So we write select star from customer where customer ID and then the greater than operator 500. This will fetch all the records with customer ID greater than 500. Select and execute. Here we can see that the result that is returned is starting with ID 501 because we have the condition of greater than 500 and the total records fetched is 99. Now if we want to include the record with ID 500 as well in the result set, then what should we do? Well, either we can change the value 500 to 499 or we can use the greater than equal to operator, and to do so we just have to add an equal to sign after greater than, and yes, there shouldn't be any space between greater than and equal to sign. Select and execute. And now we have the ID 500 included as well in the result set, and also you can see that now the total records fetched is 100 because now we have one more record with ID 500. Now let's reverse the condition. Let's fetch the records with customer ID smaller than 500. To do so, we just have to reverse the operator, that is, instead of greater than, we add less than or smaller than operator. Execute this and we can see now that the result is starting from ID 1 and the max ID in the result set is 499. Now in the same query, if we change smaller than to smaller than equal to, then this will fetch the records with customer ID less than 500, including the customer ID 500. Let's execute and there we have the result. Let's scroll down and check the max customer ID that is fetched. Oh, but why are we scrolling it when we have learned how to sort the result set? Let's sort the data using the order by clause. So we add here order by and let's sort by customer ID descending. Alright, now let's say if we want to exclude a particular record from the result set, then how do we do that? To do that, we have not equal operator, which can be written in two ways. Either we can write it as an exclamation followed by an equal sign or greater than followed by smaller than. For example, if we want to exclude customer ID 1 from the result set, then in the where condition we will add customer ID not equal to 1. Execute and here we can see that the result set is returned without customer ID 1. Even if I change the operator to this and execute it, it will return the same result. Not equal to can also work with string and other data types as well. For example, if we want to exclude the record with the first name Linda, then we can just change the column name to first name not equal to Linda. And let's execute this and you see that this name is now not included. Now there is one question or an assignment that I want to give you, and that is find records of customers whose birth date is greater than 1st January 2001 and then sort the data by birth date. So this is the query. Select star from customer. Then in where clause we will write column name, that is birth underscore date greater than value. Because the value is date, we have to provide the value in the format that MySQL understands. That is in YYYY MMDD format. So we will write 2001-01-01 between single quotes and then we add order by clause, that is order by birth date, and this will give you the result. Now we are going to discuss about the AND operator. Basically, AND operator is a logical operator which combines two or more conditions or expressions and returns 1, 0 or null. Because MySQL doesn't have any built-in Boolean type, it treats 0 as false and non-zero values as true. The AND operator returns 1, that is true if all the expressions are true, and it returns 0 if any of the expression fails, otherwise it returns null. Generally, you'll use the AND operator in the where clause of the select, update or delete statements to form a condition. Let's check this in examples. So here we will be using a film table for our examples. Let's check the columns that we have in this table. Okay, so we have release year, language ID, rental duration, and some more. So we have a good amount of fields here for our example. Let's query a simple where condition first, which returns all the records whose release year is 2000. So we write select star from film where release year equals to 2000. Execute this and here we have 20 records with release year 2000. Now further, if we want to filter this, let's say we want records only with rental duration greater than 5 Then comes the AND operator in action. Now to further filter these records, we will add AND operator and the second expression, that is rental duration greater than 5. Execute, and here we can see that now we have only 8 records which satisfies both the conditions, that is release year in 2000 and also rental duration is greater than 5. When using AND operator, if any expression fails, MySQL stops evaluating the further expressions and determines the whole expression as false. Like in this query, MySQL will first evaluate the first part of expression, that is release year equals to 2000. If the result of this expression is false, MySQL will determine the result of the whole expression as false. Therefore, MySQL doesn't need to evaluate the remaining part of the expression. Now, further we can keep on adding conditions to it. Let's say we want only records with PG-13 rating. Then we add one more AND here stating rating equals PG-13. Let's execute, and now we can see that we have only 3 records which satisfies all the expressions in the where condition. Alright, so now we have 3 questions here which are assignments. So the first is select records from the film table with release year greater than 2005 and replacement cost greater than 20, and also the length should be greater than equal to 100. So this is how the query can be written. The second assignment is select records from film table where language ID equals to 1 and release year is smaller than 2000. So this will be the query for the same. And let's try one more assignment. That is select records from the film table with release year between 2005 and 2010 and sort the data by release date in descending order. So here we'll be using the query like this, where we give the AND operator in between, and also we'll use the order by clause and use the descending, that is DESC. What will the AND operator return if the condition is true, and what will it return if it is false? The AND operator returns 1, that is true if all the expressions are true, and it returns 0 if any of the expression fails, otherwise it returns null. In this lecture we will learn the OR operator. Like an AND operator, OR operator is also a logical operator which combines 2 or more expressions or conditions, and it returns 1, 0 or null. The OR operator returns 1, that is true if any one expression is true, and it returns 0 if none of the expressions are true, otherwise it returns null. Like the AND operator, OR operator also stops evaluating the remaining parts of the expression as soon as it can determine the result. That is, if the first expression returns true, MySQL will stop evaluating the second expression. Let's check this example. So again, I'm going to use the film table for the examples. Let's say if we want to find records of the film that were released in 2000 or 2005. So I write select star from film where release year equals to 2000 or release year equals to 2005. Let's execute, and here we have 69 records with release year 2000 and 2005. Let's sort this data by release year so we can easily identify the records. So we add an order by clause. I'll say order by release year. Execute this, and we can see that the result is now sorted with release year. Alright, we can also combine AND condition with OR condition. Now when the statement has both the expressions, that is and OR, MySQL will evaluate the expression with the higher precedence first. Since the AND operator has higher precedence, MySQL will evaluate the AND operator before OR operator. Let's check this example. Let's say we want to find the records with release year 2000 or 2005 and language ID should be 1. So basically we want all the records with language ID 1 and release year 2000 or 2005. Let's start querying. I'll say select start from film where release year equals 2000 or release year equals 2005, and then we will also add and language ID equals to 1. Also add the order by clause here on release year. Now let's execute and check if we are getting the result as expected or not. And here we can see the result. Now is this the result set that we expected? Absolutely no. Here you can see that we have records with language ID other than 1 as well, but we wanted the records only with language ID 1. That's because, as I said earlier, that when we have and OR operators together, MySQL will evaluate the higher precedence first. That is, in this statement, release year equals 2005 and language ID equals 1 is executed first, and then the OR condition is executed. Here we see that for release year 2005, we only have language ID 1. Okay, so to correct this, we have to combine the expressions in parentheses that we want MySQL to evaluate together. So here we will put release year equals 2000 or release year equals to 2005 in parentheses. And now let's execute this again, and here we can see the result. Here we can see that we have records only with language ID 1 and release year is 2000 and 2005. Now let's talk about few questions and assignments. So the first assignment is select records from the film table where the language ID is 1 or 6. So certainly you will be using the OR operator here, and here is the query. The second question is select records from the film table whose rating should be NC17 or PG13 and the release year should be greater than 2015, and then sort the result by rating and release year in descending order. So if you have to do that, certainly the condition will go something like this, where you put the parentheses where you say rating is NC17 or PG13 and you join the condition with AND operator now and just say release year is more than 2015, and you just say order by rating and then release year in descending order. So that's how you can get the result for this question. Okay, so here in this lecture we will be learning the in operator. The in operator allows to determine if the values are present in the given list of values. For example, if 1 is present in list of values, that is 1, 2, 3. Talking in simple terms, in operator is functionally equivalent to the multiple OR operators. Other than select, update and delete, in operators are also used in subqueries, which we will see at a later stage. So let's check the in operator example. Let's say if we want to find the records from the film table with PG or G rating. So we write here select star from film where rating, and then we will add in operator and then provide the list of values that we want to fetch inside parentheses. So here open the parentheses and provide list of values, that is PG inside single quotes as it is a string, comma another value G, parentheses closed. Let's execute this, and here we have results with PG and G rating. This query is also equivalent to select star from film where rating is equal to PG or rating is equal to G. This will give us the same result as we get using inQuery. Let's execute and we see the same result. Here we just have two values, but in case the list has many values, like if we have some more values to include in rating, then we need to construct a very long statement by adding multiple ORs. Instead, we can add the values in the list of in operator. Hence, the in operator allows us to shorten the query and make it more readable. In operator can also be used if we want to exclude the values in the list by adding not keyword, that is the not logical operator, as a prefix before in operator, that is not in. Let's say instead of fetching all the records of rating PG and G, we want to fetch all the records excluding PG and G, that is other than PG and G rating. Then we just have to add a not before the in. So instead, let me write a new query. I'll say select star from film where rating not in PG, G. Let's execute this and we see the records without PG and G rating. Basically, this statement is equivalent to select star from film where rating not equals to PG and rating not equals to G. So if we execute both these queries, we'll get the same result set. So in is a very commonly used and very useful operator while querying the data when you have more OR conditions. Now let's talk about a question that is an assignment. The assignment is fetch records from the film table where release year is 2000, 2005 and 2010, and also it should not include PG and G rating, and then sort the data by release year ascending and rating in descending order. So here is the query. You just write the in operator for release year, join it with another and. We have the rating not in and you give the PG and G, and let's also sort it, that is order by release year and then by rating but in descending order. In this lecture, we will see how to use the between operator to check if the value exists in the range of values. So basically, between operator is a logical operator that specifies if a value exists between two given values. Between operator is generally used with numeric and DateTime data types. Let's say, for example, we want to find the records where release year is between 2005 and 2007. Then the query would be select star from film where release year between 2005 and 2007. When using between operator, the values are inclusive, that is here 2005 and 2007 are inclusive. That means the records with year 2005 and 7 will also be fetched. So let's execute this, and here we have 153 records in the result set. So this query is equivalent to select star from film where release year greater than equal to 2005 and release year is less than equal to 2007. Alright, now if we want to reverse the condition, say we want to get the records that don't fall between the given range, then we can add not prefix with between. So let me write a new query. Select star from film where release year, and here instead of between, I will write not between 2005 and 2007. Let me increase the value so it is easier to check the records. Let me make it 2001 and 2019. So basically this query is equivalent to select star from film where release year smaller than 2001 or release year is greater than 2019. Let's execute both the queries, and here we can see that we have records smaller than 2000 and greater than 2019, and both the result sets are same. Now let's talk about question or assignment. The question is fetch customers whose birth date falls between 1st January 2000 and 31st December 2001 from the customer table. Here we have to use the date format which is accepted by MySQL, that is 4wise DDMM format. So here we will write select star from customer where birth date between, then the date will be in YYYYMMDD format, that is 2000-01-01 and 2001-12-31. Now let's talk about another very important operator, and that is the like operator. Like operator is basically used to test if a string contains a specified pattern or not, and to do this there is a wildcard pattern, and that is %sign. For example, if I write %, that is like this, it means it will match any string that starts with M, such as MySQL, Maple, etc. The placement of %sign in like operator can be placed as per the need or requirement. Now the question is, when do we use like operator? Assume you want to find some records but you don't know the exact value of what you are finding. You just have some basic idea of the value. For example, you want to find records whose title is starting with A or ending with A. Let's check this with example. I'm going to use the customer table. Let's say we want to find all records whose first name is starting with A. I'll say select star from customer where column name, that is first name, and then we will add like operator, and in single quotes I'll write A and then %sign. Generally the like operator is used with string data types, so we have to write the expression values in single quotes. Now let's execute, and here we have 44 records matching the criteria. In the records we can see that all the records are starting with A. Now suppose we add M here. So now the condition is AM %. Well, we know that MySQL is case insensitive, so we can write this in lower case as well. So I can say AM % like this. Now let's execute, and you see that there are only 3 records that are starting with AM. Now if we change the placement of %, let's put it in the first place and check. So now here we have some records that end with AM. We can combine like with not operator to reverse the condition, as we did in our previous lectures for not in and not between. So for example, if I want to find the records that do not start with AM, then we have to add the not operator before the like. So the query will be select star from customer where first name not like AM %. Let's execute, and here we have the result set that is not starting with AM. Other than %, we also have an underscore character that we can use with like operator. The purpose of the underscore is it only matches a single character. As in this example, if I change this where condition to underscore y, that is select star from customer where first name like in the quotes underscore y. So this will exactly search only for two characters in first name. So here underscore can be anything followed by y and is only two characters. Let's execute and we don't have any records. Obviously that's because we don't have any two characters first name in our table. Okay, let me put few more underscores. Let me add two underscores. So now we have total 3 underscores and y. So now it will search for records where the first 3 letters of first name could be anything followed by y. Let's execute and check. Okay, so here we have the records with 4 characters. The first 3 characters are random alphabets followed by y. So the percentage and underscore both are used with like operator. Percentage represents any number of characters, whereas underscore represents a single character. Now let's talk about few relative questions. So what is the difference between the percentage and underscore in the like operator? So the percentage and underscore both are used with like operator. Percentage represents any number of characters, whereas underscore represents a single character. The second question is get the records from customer table where first name contains on anywhere in the name like Tony, Sony, etc. So to do this, we'll write select star from customer where first name like ON and then we add percentage before the letter O and after the N because we want that on can be anywhere in the first name. And let's execute so you see the result. So this is how we use the like operator for string or pattern matching. We have learned the like operator to match any string pattern using percentage and underscore. There is also another type of pattern matching operator which is much more powerful and dynamic than like operator because it is based on regular expression, and that operator is the regex operator. If you are aware of any programming language or scripting language, then it will be very simple for you to understand. If you also want to learn regular expression through JavaScript, then I have a dedicated course for regex. So for example, if we want to find the records from customer who has do, that is DO in their first name, the syntax would be select star from customer where first name regex, that is regular expression, and then we simply write do between the single quotes. Now this is exactly the same as this. Execute and here we have only records matching the criteria. Now if I comment this line number 3 and execute this with like operator, it will give the same result. No, we have different characters to do different things in regex. Like we have caret sign which indicates the start of the string. So say for example, if we put a caret sign just before the word do, that means the first name must start with the word do. So if we execute this, we will get the records beginning with do. We also have a $sign which represents the end of a string. That means if I put a $sign after the word do, that will match records whose first name end with do. So Here this DO dollar expression means that the first name must end with DO. Let's execute, and here is the result. Now we can also search for multiple strings here. Say for example, if we want to find the records who have DO or LOT, that is lot or tin, TIN, in their first name, then we have to use pipe sign and then the next pattern. So after the word DO, we will add pipe here and then the next expression, that is LOT, lot, and then pipe once again, then again the next expression, that is tin. Now let's execute this, and here we have records with DO, LOT and tin in the first name. Alright, now we can take this to a next level. Let's say in this first pattern, we want the first name to end with DO. So let's put a dollar sign here, and also say in this third pattern, we want the first name to start with tin. So we put a caret sign before the word tin. So this expression will fetch the records where the first name ends with the word DO, that is do, or the first name has the word lot, LOT in it, or the first name is beginning with the word TIN, that is tin. Okay, now let's execute this, and here we have 7 records matching the criteria. The first record is starting with word tin. Then in the second record we have a LOT, lot here, and rest of the records are ending with the word DO. Let's check one more example. Let's say if we want to find the records with letter E in it, and also make sure that before the letter E it should have letter I, O or U. So to make this expression, we will add square brackets, and in between we can have multiple characters that we want. So we will write here I, O, U. So basically this will match any record that has I, E or O, E or U, E in the first name. Let's execute, and here we have the result. Now it is not necessary to have this square brackets before the letter E. We can also put this after the letter E. So this will fetch records which have E, I, E, O or E, U. Let's execute, and here is the result. So this is how we can deal with regular expression. As I mentioned, you can get in-depth idea using JavaScript of regular expression in one of my dedicated tutorials on regular expression itself. Basically, regular expression has many more combinations. In a single lecture it would be difficult, but it's easy to understand with various pattern matching. So here are some of the characters that can be used or combined to make more complex expressions. So this is the pattern, and here is the explanation. Like for example, the caret which we have seen, and that actually shows the beginning of string. Dollar is for end of the string. A dot is for a single character. Similarly, there are various other combinations which you can try from this table. Now let's talk about few relative questions. The question is, what is the difference between like and the regex operator? So the like operator can help for pattern matching search, but if you compare it with regular expression, then I must say regex operator is far advanced and with more and more functionalities with various types of pattern matching. Most of the programming languages also have regular expression these days for pattern matching. Like operator has a very limited approach, whereas regular expression is a vast variety of pattern matching. Now the next assignment is get records where the first name should start from a letter between A to F and should contain exactly 4 letters. So let's begin. I'll say select star from customer where first name, then regular expression. Let's make the expression now. Okay, so our name should start with A to F. For this, we will add a caret sign first to match the beginning of the string, and then the character should be between A to F. So here we will add a square bracket and give the range of words. So we write A hyphen F. Okay, so if we execute this, we will get all the records which are starting from A, B, C, D, E or F. But we want to find the names which are of exactly 4 characters. So now in this expression, after the square brackets, we will put a dot, that is, it will match any single character, and this we want to repeat for 3 times. So we put a curly bracket and write 3. And then we end the string after 3 characters. So we put a $sign. Now if we execute, we have the names with exactly 4 characters and starting with letter A to F. The next assignment is get records where the first name should not contain letter E, N or A. So for this, I'm going to say select star from customer where first name, then the regular expression. Now first let's find the records which are starting with E, N or A. So it's pretty simple. Between the quotes we write E separated by pipe, then N and again pipe and A. So now if we execute this, we get all the records which has E, N or A in it. But the assignment is vice versa. So what we will do? It's extremely simple. We just add the not keyword before the regular expression and we are done. And now if we execute this, we have the records without letter E, N and A. In this lecture, we will learn how to constrain the numbers of rows returned by a query. As we know that when we write a query with or without condition, it returns all the rows with matching criteria in the table. Let's say if we execute select star from film, it will return all the records in the table, but suppose we want to get only the first 3 records from the table, then we have a limit clause. Basically, the limit clause accepts 1 or 2 arguments and the arguments must be positive number. The first argument is offset, that is how many rows to skip, which is optional, and the second argument is the number of rows returned, that is how many rows we want in the result set. If we just use the limit clause with only 1 argument, MySQL will treat this as the number of rows to be returned. Okay, so here if we add limit 3 and execute this, it will return us only 3 records, that is the first 3 records. Now let's assume that we want to implement pagination with 5 records on one page. So on page 1 we will have records 1 to 5, on page 2 we will have records 6 to 10, on page 3 we have 11 to 15 and so on. And if we want to query on page 3, that means we want to get the records from 11 to 15, then we will add the first argument, that is offset, in the limit clause. So here I will add 10, that is I want to skip the first 10 records, and then comma 5, that is to return the number of rows. Now if we execute this, we will get records starting from film ID 11. Alternatively, we can also write this query in this format, that is limit 5 and then offset 10. Now let's talk about relative questions. So the first question is, what is the offset in the limit clause and how do we use it? Offset means from where to start fetching the records from the result set. Basically, how many records do we want to skip before getting the actual data? To use the offset, we can pass it as a first argument in the limit clause with the number of rows to be returned. Limit 2, 4, where 2 is offset and 4 is the number of rows returned, and also alternatively we can use the offset keyword this way, that is limit 4 offset 2. The next question, that is the assignment, is get the fifth highest record from the film table by its length and replacement cost. So first of all, let's simply write a select query, that is select star from film. So this will return the whole table. Now we want to find the fifth highest record by its length and replacement cost. So to first find the highest length, we have to add order by. So we are going to add order by length descending, because we want the max length on the top right, and because we want the record in combination where we have the highest length and also highest replacement cost. We will add replacement cost as well in order by, and this will also be descending. Now let's execute this and we have the result here. Now instead of star, let me put specific columns that we want to make it more readable. Now let's execute. So now we have the sorted data. The next step is we want the fifth highest record. So how will we do it? Basically, fifth highest means we want to skip the first 4 records and only get the fifth record. So now we add limit clause 4, 1, that is skip 4 records and get only the fifth record. So now let's execute, and the result is film ID 690. We can verify this by removing the limit clause once again and execute 1, 2, 3, 4 and 5. So our fifth highest is film ID 690. Excellent. Now the order of all these clauses cannot be changed. The limit clause will always be the last clause in the select statement. First we will have the select, then the from, then we have where condition, and then order by, and finally you put limit. If we try to change the order of any of these clauses, MySQL will throw us a syntax error. So this itself is one more question, that is it possible to change the sequence of limit? So certainly we cannot do that. In this lecture, we'll be learning the is-null operator. Basically, the is-null operator is used to check if the value is null or not. That's simple. Now we have already learned that null is different from an empty string or 0. Is-null will check only the null values. That is, if I write select 1 is null, will return 0, that is false. Even if I write null as string and execute, then also it will return 0. But if I write null is null, then it will return 1, that is true. Let's check this example. So let me open the address table and add few null values. So we can check this at a later stage by querying it. The query would be select star from address where address 2 is null. Let's execute this, and here we have the result with null values. Here if we try to compare it using equal to operator, we would not be able to get the correct result because is-null only works with null type values. Now what if we find the values that are not null? Well, it's very easy. We just have to add the not keyword before null. So the condition would be where address 2 is not null. So let's execute this, and we have the result where the address 2 is not null. Now let's talk about the assignment and questions. So the question is, with which data types can we use the is-null operator? Well, we can use this with any data type, right? Because is-null is going to check whether there is any value which may be a string, a number, a date or whatever, or else it might be null. So if it is null, then the operator will work on that field. Now let's take one assignment also. Find records from the customer table where the birth date is null. So it's pretty simple. Just say select star from customer where birth date is null. And here we have the result. Sometimes it might happen that the column names are so technical that it becomes difficult to understand the output of the query. Sometimes there might be expressions included as a column name. So to give the columns or tables a meaningful or short name, we can use aliases. So basically, alias is just a descriptive name for tables or columns. This is very useful when dealing with the large queries. To give alias, we have to use the as keyword followed by alias. Let's say if I write select 10 multiply 10 and execute, you can see here that the column name is displayed as 10 into 10. So this column name does not provide proper information that one can understand. So to give this expression some proper name, we will use the alias here. So after this we will add as and then the alias. We give it a name multiplication. And now if we execute, you can see that the column name is now displayed as multiplication. Here as keyword is optional. Even if we write the alias without as keyword, we'll also give the same result. Let's see one more example. Let me add one more expression, concat first name comma space comma last name, and execute and see the column name. Now we can also give alias with spaces, but to give aliases with spaces we have to enclose the alias by single quotes, double quotes or back quotes. Execute and here is the result. Now the same way as we gave the alias to columns, we can also give aliases to tables, like select star from customer as C, where C is the alias for the customer table. Once the alias is assigned to the table, we can refer the columns by the alias name itself, like C.firstname, C.last name. Aliases are often used when using joins. We will see aliases in action in our upcoming lectures when we will use joins and expression columns. Let's try one assignment here. How to assign aliases with spaces. So we can assign aliases with spaces by wrapping it between single, double or back quotes. Until now, we have just learned how to query or fetch records from a single table. But because we are dealing with RDBMS, and as the name itself is self-explanatory, that is relational database management, it is but obvious that it will be having multiple tables that are linked with each other through some common columns, which is referred as foreign key. We have already gone through the details of foreign key in our previous lectures. Okay, and because of having a relational database, that is parent-child relation, the data in each table is incomplete without each other. For example, an e-commerce site. This has always been the best example for understanding this kind of complex database. Okay, so in e-commerce we have orders and order details and customer table which are linked with each other using some common columns, like order ID is linked with order details and customer is linked with orders. So to get complete information of orders in one go, we need to query from all the tables, and that's where join comes into action. So in short, join is a method of linking data between one or more tables based on values of the common columns between the tables. The basic syntax of join is you say select star from table name, join, then the table name, then you have the on keyword and condition. There are different types of joins which we will learn in detail in our upcoming lectures. So let's begin the journey of understanding the most important concept in RDBMS, that is joining the tables. Now let's talk about questions. So what is a join command and when can we use join? Join command is used to join, or we can say combine, data of two or more tables in a single result set. We can use joins when tables have at least one column in common between them. So now let's begin with inner join. Now we know the basic idea of joins. Basically, join is to link multiple tables using the common field between them. So what is inner join and how does inner join work? Inner join compares each row from table 1 with every row in table 2 based on the condition provided. It means if both the tables have the row with common values provided in the join condition, the inner join will create a new row from both the tables and return it in the result set, and if any row value that is not present in the second table will be ignored. Let's check this example. So first of all, let's check the table structure using show create table customer. So here we have customer table which has a reference of address ID from address table, and customer table address ID is referred to address ID in the address table. Now let's begin the query. I'll say select star from customer, and now we will add the join here, that is inner join child table, that is address, and now the condition join on what? Joining on customer dot address ID equals address dot address ID. That means match the records where value of address ID in customer column is equal to address ID column in address table. Now this query will return us the customer along with their address details. And because we have returned star instead of columns, it will return us all the fields from both the tables. Let's execute and check this. So here we have the result. So here we have customer ID 1, store ID 1, and we have address ID 5. And as we keep scrolling, we see that after the last update column, we have the fields from the address table with address ID 5. So basically the address against this customer is this. Let us add only a few columns instead of star here. To do that, we have to add table name dot column name, like from customer table we want customer ID, first name and last name. So we add customer dot customer ID comma customer dot first name. Now writing a table name with a dot becomes very cumbersome when we have long list of columns. Instead, we can add alias to the table name like we will be doing here. So add an alias after the customer. Let's say customer as C, and to the address table, let me give the alias address as A. As is an optional keyword here, but to make it readable, we are adding as keyword here. So now instead of customer.customer ID, we can write c.customer ID. Let me add the other column as well, and from the address table we want the address, so we add a.address and a.postal code. Now let's execute this and you see the result. Now let me also add c.address ID as address in customer and a.address ID as ID in address, just to understand how inner join works. Let's execute, and you can see that the address ID in both the tables are matching for all the records. And that is how inner join works. It checks if the value of the columns provided in the condition are the same or not. Now to make it more clear, let me do one thing. Let me remove the address ID from customer table for customer ID 1. So let me quickly update the customer table. I'll say update customer. Let us set address ID equal null where customer ID equals 1. Now let me execute this update query. And now let's execute this query once again and check. So in this result, we can see that record with customer ID 1 is missing in the result set. That is because it does not have any matching or related records in the address table. Now in this, we can add multiple conditions and multiple joins as well. Let's say in this join, if we want to get records where the address ID should be between 10 and 20. So in this condition, after c.addressId equals to a.addressId, we can add more conditions as we do in the where clause. So after this, we will add and a.addressId between 10 and 20. Let's execute this, and here is the result. We have only records which are in both the tables, and also the address ID is between 10 and 20. So this is the basic idea about inner join. Now let's discuss few questions and assignments. So the first question, that is the assignment, is get the records from the customer table with address and city name, and also the address too should be null. So let's begin the query. So I'll say select star from customer as C, that is I'm giving the alias name. Now join address as A, that is again an alias, on which column? So c.addressId is equal to a.addressId, that is address ID column value from customer table should match with address ID column value in address table. Okay, so is this the right query or did we miss anything? Oh, we missed the inner keyword here. Well, no worries. By default, if we just write join, it will be treated as inner join only, so you can skip the inner keyword. Okay, let us add only the column that we need. So we add c.customerId, c.firstname, c.lastname, and a.address and a.address too. Well, it is not necessary to write c.customerId or c.firstname if we have unique columns from both the tables. We only have to give the reference of the table if we have common column names in both the tables. But it is always a good practice to write column names with reference to quickly understand that from which table this column is coming. Okay, let's execute this, and here are the records, but we want the records where address 2 is null. So we add a condition here, and a.address 2 is null. Now let's execute, and there we are. Now what else we want? We want the city name. Let's check if we have a city name in the table or not. Okay, so we don't have a city name, but we have a city ID. So first, let's check the table structure to do that. We will write show create table address. Okay, so here we have a foreign key city ID, which is referenced to the city ID column in the city table. So we add here one more join after the condition. So join which table? City table. Join city as CI, because we cannot have the same alias name in a single query, or else it will give us syntax error. Alright, and then the on condition on ci.cityid equals to a.cityid. Now why a.cityd? Because the city ID is referenced in the address table as well. Also add column ci.city. Now let's execute this, and here we have the complete result set for the given query, which actually gives us the solution for the question, that is the assignment. There is also one more question, that what happens if I do not use the inner keyword with join? So as I mentioned earlier, inner is the default join. So if you do not specify inner or outer or any other keyword, and if you just give the join keyword, it means it's going to perform the inner join. The same question can be asked, that which is the default join if you just give the join keyword. So it is the inner join which is the default join. Similar to inner join, left join is also used to join two or more tables. When using left join, the concept of left table and right table is introduced. So basically the left table is the table that comes first before the table mentioned in join. For example, select star from table 1, left join table 2 on condition. In this query, table 1 is the left table and table 2 is the right table. In other words, the table mentioned first is the left table for the table mentioned in join. Like in this query where we have multiple joins, select star from table 1, left join table 2 on condition, left join table 3 on condition, left join table 4 on condition. In this query, table 1 is left table for table 2, 3 and 4. Table 2 is left table for 3 and 4, and table 3 is left table for table 4. Now when to use left join? So when we want all the records from left table, even if the record does not exist in the right table. Let's check this through example. Let's first write a simple inner join. I'll say select star from customer as C, join address as A on C.addressID equals to A.addressID. Let me add column in place of star. I'll say C.customerID, C.firstname, C.lastname, A.addressID, A.address2, and also add A.postal code. Alright, let's execute this, and here is the result. Okay, so here we can see that there are some records missing, like customers with ID 1, 4, 8, 10, etc. are missing in the result set. That means the records for these IDs are not present in the address table. But still, if we want those records in the result set, then we have to use left join. And to do that, we have to add left here. So now it is left join address. Now let's execute this and you see the result. Here we can see that we have all the records, including the customer records who don't have address ID. And for the records that don't have address ID, the values in those columns are null for the address table. So this is what left join is all about. The question is, what is the difference between inner join and left join? So inner join returns the records which have their occurrence in all the tables that are joined, while left join returns all the records from the left table, even if no matching records are found in the right table. Right join is very similar to left join, except that the treatment is reversed in right join. That means right join will return all the records from the right table. So basically the concept of the left and right table remains the same. For example, select star from table 1, right join table 2 on condition. In this query, table 1 is the left table and table 2 is the right table. Let's check this through example. Let's write the query. I'll say select star from customer as C, right join address as A on C dot address ID equals A dot address ID. Let me add the columns instead of star, that is C dot customer ID, first name, last name, A dot address ID, address and postal code. Alright, so basically this will fetch all the records from the address table and match records against it from customer table. Let's execute this and here is the result. Here we can see that we have all the records from the address table and the customer table is null where no matching records are found. Well, in my many years of experience, I have rarely or perhaps you can say never used right join. Even in this case, the result we see actually does not make sense. The result shows the address has any customer associated with it or not. Actually, the other way around, it should be a list of customers with their address. Though this result can be achieved by swapping the orders of the table, like keeping the address table as left table and customer table as right table. But then the query does not make any sense because technically the master table should come before the child table. When we have large queries with multiple joins with multiple tables, it will be hard to visualize the query if the master table sequence is not maintained. So it's better to avoid right join from my perspective, and instead we use left join, and that's what you see developers doing often. Alright, so until now we learned how to combine data from different tables using joins. Now here in this lecture we will see how to do a self join, that is joining the same table through some column. Now when these types of joins are used, basically this join is used when you have hierarchical data, that is tree structure. For example, product category, like you have books as one category. Then you have comic, which is again a category but is referenced under books. Then you have one more like kids learning, which is also category and is referenced under books. Or you can take example of employee table where you have employee ID, employee name and reports to column, and in the reports to column we have the value of employee ID itself. So the data would be like employee A reports to no one, employee B reports to employee A, and so on. Alright, so to check this, I have created one product category table in NJSampleDB database. Okay, so here we have ID, category name and parent ID, and in the parent ID column we have ID column values from this table itself. So if we want to find the category with their parent category, then what should we do? Basically it's very simple. We have to use the join which we have already learned in our previous lectures, and that's it. So let's check this. I'll say select star from product category P. Now what next? Next is we join the table, but which table? Yes, the product category table itself. So we write join product category P1 on. Now on what? On P dot parent ID equals P1.id. That is, the parent ID should match the value of the ID column. Let me change the columns P dot category name, P1 dot category name, and alias as parent underscore category. Let's execute this and here is the result. We have comic and parent category is books. Then we have Marvel whose parent category ID is comic. Something like that. Now let's talk about questions. So how self join is different from left, right or inner join. The differences in left join or inner join, we join two different tables. But in self join, we are joining only one table, that is the same table, rest all other things remain the same. Now let's discuss one assignment as well. Write a query to get all records from the product category table with or without parent category. Okay, so here in the query, select p.id, p.category name from product category P. Now join again product category P1 on p.parent id equals p1.id. So that means parent id should match the id in the same table. Let me add columns from P1 as well, p1.category name, and give this an alias parent category. Okay, let me tell you one more thing here, that it's not necessary to have the same column name to make a join. In real world data structures, we always find different names referencing each other. Alright, now let's execute this, and here we have the categories with their parent categories. These records are all with parent, so what about those categories which do not have parent ID? So to fetch that as well, we need to do a left join here. So let me write a left join. Now we execute this and here is the complete result. Until now we saw inner join, which gives us matching records from multiple tables. Left join, which gives us all records from left table. Right join, in which we get all records from right table, and we also saw a situation where we try the self join. And now what? What is there that is still remaining, still missing? Well, what do we do when we want records from two tables without any condition? By now you might be wondering, what am I talking about? Let me give you one example. Assume you have a product with some attribute and value, like you have a product shirt which has an attribute that is color, and you have size which is available in all colors. So assume that you have some sort of data structure like this, and you want all the records from colors and size. So basically you want the result something like this. Then we have to use cross join. Basically this will combine tables. Each row from both the tables, that is each row from table 1 will have each row from table 2. Let's check this example. Let me write a select query on the product table. Select star from products. Let's execute, and here we have 9 records in the product table. Now let us check the same in product category table. I'll say select star from product category. Let's execute, and here we have 25 records. Alright, now let us write a cross join on this. So we have select product name from products, then cross join product category, and let me also add the column here, comma, category name. Alright, so this should return us all the combination of records from both the tables, that is 9 records from products multiplied by 25 records from product category. So this should give us 225 records. So let's execute and check, and here is the result. So we have all the products in the all categories. You may also notice that we have not used an alias here, That's because we are using just two columns from both the tables and the column names are also unique, so there is no need of providing an alias. Okay, now here we have written cross join explicitly, but if we don't want to write an explicit join, we can ignore this line and simply add the second table name in the from clause itself, separated by comma like this. So let's execute, and this will also give us the same result. Now there is an assignment. So for this assignment you have to use the Sakila database. So the assignment is that you find all the films released in the year 2000 and the length of the film should be greater than 50 and smaller than 65 with the combination of all the languages, first using explicit and then implicit join. Well, this assignment may not be that hard, but I just want to get your hands dirty. Alright, let's begin. First, let's query to get the films with the condition mentioned. So select title, release year, length from film where release year should be 2000. So release underscore year equals 2000 and the length should be greater than 50 and smaller than 65. So add one more condition and length between 50 and 65. And now we want this to combine with all the languages. So here before the where condition we will add a cross join table, that is language. Also let us add the column here name as language. Let's execute, and here is the result. So this is an explicit join. If we want it to be used implicitly, we remove the cross join from here and add the table name after the film table separated by comma. Let's execute and we get the result. In this lecture, I am discussing about group by clause. Basically, the group by clause is used to group the rows that have the same set of values and return it in a summary row. For example, the total number of customers in each country, or maybe an average salary of a particular department or average salary of all the employees. Generally, the group by clause is often used with aggregate functions like count, max, min, etc. to group the result set by one or more columns. Let's check this practically. Let's find total number of films released in different years. So we start with a basic query first. I'll say select star from film. Let's execute. Okay, so here we have all the records. Let me add order by for more clarity. So I'll say order by release year. Now let's execute. And here we have the sorted data. We can see here we have multiple records of the same release year. Now let's group this by release year, so we have only one record of release year. So we add group by clause here before order by, because order by is always the last clause in the select clause. This we have already discussed in our order by clause section. Alright, group by column, that is release year. Let's execute. And now we can see here that we have only one record for different release year. Now one most important thing when using group by is that we should use only the columns that is needed in the select clause, because as we can see here, apart from release year, other columns do not make any sense in the result set. So let me remove the star and add the release year. Now let's execute, and here is the result. Alright, now we have only a unique release year, but this is not what group by clause is meant for. We have different clauses to get unique records. So unless we use it with any aggregate functions, the group by clause is not going to make any sense. So let's add a count function here and check now. Let me write count star and give this some alias like total films released. Execute this and here is the result, which is more sensible now. Like we had 20 films released in 2000, 55 in 2001, etc. Let's quickly verify these records. So I'll write a select query, select star from film where release year equals to 2000. Let's execute both the queries. Here we can see that we have 20 records in 2000, and here in the group by query also we have the same count. So this gives you some basic idea how and for what purpose the group by clause can be used. There are also other aggregate functions which we will see in the forthcoming sections. Now let's talk about the assignment. So the assignment is get total number of films by its length and release year. So here in the query, select release year, length, count star. I'll give an alias, total film from group by release year. Let's also add order by release year and execute this. And here is the result. But wait, is this the result we wanted? Absolutely no. We wanted the count by different length as well. So what do we do now? Pretty simple. We will add the length column in the group by clause. So it will be group by release year, comma length. So the records will be grouped by release year and length, and we will have unique row with release year and length, of course. Execute this and now we have the result with release year, length and the total number of films in that. If we want to verify this, we can verify by querying on film table, like for release year 2000 and length 61, we have 2 films. So let's query and check. Select star from film where release year equals to 2000 and length equals to 61. Let's execute and we can see that we have only 2 records with that combination. There can be another question also. What is the purpose of group by clause, or how do you get the aggregate or summary result within a query? So it is the group by clause which gives you summary on a specific field. For example, you want to find total salary of all employees. Maybe you want to find the sale categorized by product. These kind of data, when you want to populate, you can use the group by clause. In MySQL, we have different types of inbuilt functions to do certain operations, which are grouped into aggregate, DateTime or string functions. We might have already used some of the functions in our previous lectures like now, count, year, etc. Here in this lecture, we will see some of the aggregate functions as we are working on the group by clause. In general, aggregate functions are used to perform calculations on multiple values and return the result in a single value, like the average of all values, the sum of all values, and maximum or minimum value among certain group of values. Aggregate functions are often used with group by clause to calculate some aggregate values for each group. Let's check some of them. The first function is the count function. Basically, the count function returns the number of values in the set as per the condition provided. For example, we can use this to find the total number of records in the table, like select count star from fill. If we execute this, we get the total number of rows in the table. If we add some condition to this query, then it will return the records according to the condition provided. Like if we add here where release year is equal to 2005 and execute this, will return the counts only for year 2005. count can work with both numeric and non-numeric data types. So basically in the count function, instead of star, we can provide any column name like film ID or title or any column. But it is always good to write the primary key inside the count function, because in that case MySQL will have to evaluate only the column name provided in the count function. Well, all these small things matter when we have a large data set and queries to evaluate. Next in the list is the sum function. This function returns the sum of values in the set. The function ignores null values. We can either provide column or expression in sum function. For example, if we want to find total length of all films, then this is how we do it. Use the sum function and column name inside parentheses, that is length. Let's execute, and here is the result. Alright, the next in the list is the average function, which calculates the average value in a set of values that are not null. For example, if you want to find the average length of film, then we use the average function like this, average and in parentheses column name. Let's execute, and here is the result. Same way, we have min function to find minimum and max function to find maximum. So if we add here min column name and max column name, then this will return the minimum and maximum length of a film. So right now we have this aggregate values for the whole table. But if we want this value to be grouped by language ID, then we have to add the group by clause here. I can say group by language ID. Also, let me add language ID in the select clause. Okay, now let's execute, and here is the result with aggregate values for each language. Well, these are not the only functions we have. Many more built-in functions for different usages. Here in this lecture, we have covered the functions that are frequently used in the queries. Okay, now let's talk about relative questions. So there is an assignment here that you get min, max, average and total number of films in all the years and languages. So here in this query, I'll say select star from film. Let me add all the functions in one select only. So count film ID as total film, average length as average length, min length as minimum, max length as maximum, and let me add release year and language ID here. So let's execute, and here is the result. But wait, we want this for every year and language, and the release year and language ID column does not give us the clear idea as well. So to correct this query, we will have to add group by clause here. So group by release year and language ID. Let me put order by as well. Let's execute, and here we are. Alright, but this language ID is still not clear to me. Let me add an actual name of the language here. So what do we do now? Of course, join this with the language table. So join language. Let me give alias to film table f on f.language ID is equal to l.language ID, and in column name l.name. Let's execute this. Alright, now this is good. So in the year 2000 for the English language, we had 3 films released whose average length was this, and the minimum and maximum length of the film was this. Let's assume that in this result, if you want to show the name of the film as well. For example, in the year 2000, in English language, what were the names of the films that were released? Then how we do it? I know you guys might be wondering, oh, it is so easy, just put the column name and you are done, or any other guesses. Alright, let me just put the column name and check. Let me add f.title as films and execute. So here is the result. There are 3 films released and we have only one name here. So how do we group all the titles now? To do that, we have group concat function which concats the row values into one single column which is separated by comma. So let us add group concat title and execute. So now we have the result and here it says 3 films. Let me open the film count and check, and yes, we have the 3 names. Let me check one more. In the second row it says 5 films. Open this and check, and there it is. There is also another question, that how do you get the average, minimum or maximum value? Then we have these aggregate functions, average, minimum and maximum. So these are used to deal with getting the aggregate results. Certainly you can put a group by clause if you want the average value categorized by group of values. Explain the purpose of group concat function. So here in this example we already saw that when we have multiple results, like here we wanted to have films, so what we did, we put group concat title like this, and it helped us to get the individual values for a group of results. So basically group concat function concats the row values into one single column which is separated by comma. The having clause is actually used to filter the result of group data. In other words, if I say having clause acts as a where clause for group by clause results. Let's say, for example, if you want to find in which year and in which language more than 10 films were released, then how will you find that? So the first thing that we do here is to find the number of film releases in a year and in which language. So it's simple now. Let's first write a query to find this. I'll say select release year, language ID, count of film ID, that is total film, from film, group by release year, comma, language ID. Also add the order by release year, language ID. Now let's execute, and here is the result of count grouped by release year and language. Alright, now we want only the results where the count is greater than 10. So let us first add the where condition and check. Let me add where total film is greater than 10 and execute this. And it says the syntax error. That's because where condition should come before group by clause. Alright, so now let's try having clause. Let me add here having and then the condition. Now here either we can write the expression like count film ID greater than 10, or we can directly use the alias what we have given to the column, that is total film greater than 10. And now when we execute this, we have the result here. We can see that the results have count greater than 10. We can also add multiple conditions here in having clause, same like we can do in where clause. Like let me add here one more condition, and release year equals 2005. And now if we execute, we have the result according to the condition mentioned. Now let's talk about relative questions. The first question is, what is the use of having clause, or can you use the where condition with group by data? You cannot use the where condition with group by data because where is for individual records and not for group of data. Having clause is used to filter the group data. The second question is, can we use having clause without group by clause? Of course, yes. If we use having clause without group by, it will behave like where clause. Like in this example, if we simply write select star from film having release year equals 2005 is same as select star from film where release year equals 2005. If we execute these both queries, we will have the same result. But this is not the correct way and also is not advisable to do so, because these clauses are meant for different purposes and we need to use them at a place where it is meant for. In this lecture, I will show you how to use the MySQL subquery to write complex queries and will also explain the correlated subquery concept. So basically, a subquery is one that is nested within another query. That is a query inside a query. We can nest another subquery inside the subquery. Also, subquery can be used anywhere and must be enclosed in parentheses. Let's check this in examples. Assume that you want to find all the addresses from the United States. So here in the address table, we have a reference city ID from the city table. Now let's check the city table. So here we have a country ID reference from the country table. Now let us check what the ID of the United States is. So let me query quickly. Select star from country where country like, I'll say percentage United percentage. Let's execute and here we have the country ID of the United States. Now what next? We will query with this country ID in the city table. So select star from city where country ID is equal to 103. 103 is the ID of the United States. Let's execute this and here is the list of city IDs that belong to the United States. So we need to find the addresses from the address table with these city IDs. So it's pretty simple now. We have already learned what clause we need to use to query a list of values. So let's begin. Select star from address where city ID. Because we have a list of values that is city IDs, we will use in condition here. So city ID in. Now what? Of course the list of values. So we will add here all the 35 IDs from this. That is select star from city where country ID is equal to 103. So let's start writing the IDs. Shall we? Well, absolutely no. Because when dealing with large queries, we have a much bigger list than this and also we may not know all the IDs as well. So instead of providing explicit values, we will write a query here inside the parentheses. That is select city ID from city where country ID is equal to 103. We always have to remember one thing. In an inner query, that is subquery, we have to provide a single column name to which we want to compare values, or else MySQL engine will not be able to recognize from which value to compare and will return us an error. Alright, let's execute this and here is the result. Now here in this query, select star from address where city ID is the outer query and select city ID from city where country ID is equal to 103 is the inner query or subquery. So MySQL will always execute the inner query first and then with the result of the inner query, it will execute the outer query. In this case, select city ID from city where country ID is equal to 103 was executed first, and then with the result of this query, select star from address where city ID was executed. Now in this query we can nest more subqueries. So say for example, if we don't know what is the country ID of the United States, so instead of 103, here we can write the query itself. So it will be like country ID equals to, and then in parentheses select country ID from country where country equals United States. Let's execute, and here we have the result. So here we saw that in the first part of the subquery we have used the in operator, and in the second part of the subquery we have used the equal to operator. We have to keep in mind while writing a subquery, it should return value according to the operator. So it means while using in or not in operator, the subquery should return either a single value or list of values. Whereas in the case of all other operators, it should return a single value only. Similarly, we can use all the other operators as well when writing subqueries. Here we can also see that the inner query or subquery is standalone, which means if we execute the inner query separately, it is going to execute independently. Alright, so unlike standalone subquery, we also have a correlated subquery. In this, the subquery is dependent on the outer query. For example, if we want to find if the length of the film is greater than the average length of the films released in that year, then this is how we do it using correlated query. So first we have select star from film where length greater than, and then in parentheses select average length because we want to check if the length of this record is greater than average length or not. So average length from film, that is, here we are using the same table because we want to find the average from this table itself. So from film, and the condition where. Now where what? Where release year equals to. Now what? So here we want the value in which the film was released, and that we have in the outer query. So to use the value from outer query, first we need to give alias to the outer query table. Let me give here alias as f, and that alias we are going to use here. So release year equals to f dot release year. Let's execute, and here we see the result. Now here in this query, the inner query cannot be executed independently as it has the reference of the outer query column. So without the outer query, the inner query will be of no meaning. Also, it's not that we use the subqueries in the conditions only. We can also use subquery as a column as well. Like in this query, let me change this star to some columns like film ID, title, release year, length, and also let me add the average length for a particular year. So let me just copy this, select as a column here, and also let me give it an alias as average. Let's execute, and you see the result. We can use subquery anywhere that we can think of. We can even use the subquery in from clause as well. And when we use subquery in from clause, it is known as a derived table. Like in this query, if we add select star from and enclose this whole query in parentheses, and also when we use subquery in from clause, we need to give the derived table an alias. Like if we execute this without an alias, it will give an error that every derived table must have its own alias. So let me give this an alias and execute it again. Perfect, there we are. Though subqueries are easier to write and understand, it is always advisable to use joins instead of subqueries, as subqueries might have some performance issues in the long run when having larger tables and records. Well, it also depends on how and where you use the subqueries. Mostly you will be using the subqueries when the condition which you give after the where clause is dependent on some other value. In those cases, you prefer to have subqueries. Now let's talk about relative questions. So what is a subquery? So subquery or inner query or nested query is a query inside another query. A subquery is usually used in the where clause of the SQL statement, but also can be used anywhere we can think of, even in from clause. The second question is, what is a correlated subquery? When both the inner query and the outer query are interdependent, they are known as correlated subqueries. For every row processed by the inner query, the outer query is processed as well. In correlated subquery, the inner query depends on the outer query before it can be processed. The third question is, what are the advantages and disadvantages of using a subquery? So the advantages are, subqueries allow us to use the result of inner query in the outer query, and subqueries can simplify coding and improve maintainability and also easier to understand instead of complex joins. And the disadvantage, the query optimization with larger results. MySQL optimizer might have to perform additional processes. So in some cases, subqueries can be less efficient than using joins. Now I am discussing about the union operator. What is union operator? Basically, the union operator is used to combine two or more result sets of queries into one single result set. Only the condition is that all the queries that we want to combine must have the same number of columns. By default, union operator removes the duplicates from the result set. For example, if I write select 1, 2 union select 2, 3 and execute it, it will combine both the result set into one result set, as we can see here. Now if I add one more union, say union 1, 2 again, and execute this, it is giving the same result, that is with 2 rows only. That's because the default behavior of union operator is to remove duplicates. But if we want to include all the results, including duplicates in the result set, then we can use union all. So if you add here all after the union, that is union all, and execute, it will combine all the results including duplicates. Now let's talk about an assignment and few questions also. The assignment is, get names from staff and customer tables and differentiate it with some labels. So here in the query, select first name, last name from customer, union. Select first name, last name from staff. Let's execute, and here is the result. Let us give some labels. So let me write here customer as type in customer table query and staff in staff query. We do not need to specify column name for the second query because the column name will always be applicable from the first query. It's not even necessary that the column names must be the same. So instead of last name, we can use email here and check. So we can see the result. We have first name and email from customer table and first name and last name from staff table. Now let's talk about question also. The first question is, what is the difference between union and union all? So as discussed, union operator removes the duplicates from the result, whereas union all includes the duplicate values as well in the result set. The second question is, what is the basic rule of the union? So the basic rule to perform union is that number of columns must be same in all the queries. For this practice assignment, I have created few tables prefixed with assignment. The problem statement is that you have a product stores and order table. There is a relation between product and orders table and store and orders table. There is no relation between product and store table. Basically, you have to assume that the product is sold in all the stores, so there is no need to create a relation between them. Now the assignment is that you have to find the total sales amount and total quantity sold in all the stores for all the products. Before you go through the solution, please try on your own with whatever you have learned, and then you should refer the solution. Did you try that? Alright, so let's begin the solution. Let us first get the total sales and total quantity sold. So here we have products table, store table and orders table, and in orders table we have a reference of product and store ID. So first thing we want to find here is total sales and quantity, and that we have in orders table. So select star from assignment underscore orders alias AO, and now let us join product and store table to get the product name and store name. So we are going to use inner join here. You can skip the inner keyword here and you know why. So join assignment products AP on AO.productID is equal to AP.ID, and join assignment product store alias APS on AO.productStoreID is equal to APS.ID. And now let me add the column as well, product name, comma, store name, comma, AO.star. Now execute, and here we have the list of all the orders. Now what do we want? Now we want total sales and quantity, and that too store wise. So we have to use the aggregate function here because we want to find the total quantity. So we will add here some quantity as total quantity, and for total sales we will add some quantity multiplied by price as total sales. We have price column in product table, and then we will add group by because we want the total sales and product quantity store wise. So here we are adding group by, of course, AO.productID and AO.productStoreID. Before we execute, let me remove AO.star. We do not want any unwanted columns here. Let's execute and you see the result. Alright, but this query is not giving us a 360-degree overview of product sales. Here we are not able to find which store is not having any sale for the product. So how do we find that? Can we use left join instead of join? Well, no, because we don't have any relation between product and store table. So to have the combination that returns all stores with all the products, we need to use a cross join here. So let me write one new query here which will return us all the stores and products. I'll say select store name from assignment product store, cross join assignment products. Let me also add product name as well. Okay, now execute this, and here we have all combinations of stores and products. Let us sort this by store. So let me add an alias to both the tables A and B, and then order by a.id and execute this. Now that's perfect. Now we have two different queries, one that is returning us the combination of stores and products, and the other with total sales and quantity. We want these queries to be merged with each other. So basically we have one query with all the stores and products and the other query with sale results. So now we can combine both the queries using join. So after this cross join, we will add one more join here. So join and then what? Join, and then we want to add this whole query in join, which itself is having multiple joins. So now here we are going to use subquery. So after the join parentheses, and then we will copy this whole query inside parentheses and give this an alias as C. We are not yet done. We need some common columns from the C table to join, isn't it? So we will add ao.product_id and ao.product_id in this subquery. So now when we execute this query individually, we have this result which has store ID and product ID. So now we can join this using c.product_id is equal to a.id and c.product_id is equal to b.id. Also we need to add total quantity and sales column in the select list. So let me add here c.total quantity and c.total sales. Also now we have to add alias for store name and product name as well, or else MySQL will return us ambiguous error because they are present in subquery as well. So let me add a.storename and b.productname. And now let's execute this. But still there is the same result. So now what is left? In fact, now we want all the records from the stores and products, that is from the left table. And for that we need to use left join here. So let's put a left join. So you will have all the records from the left table, and now execute this, and here is the complete result. Now we can identify which store has sales and no sales for which product. Now I am discussing about stored procedures. What are stored procedures and why do we need it? Stored procedures are functions which can be stored in the server. It is a method to overcome repetitive tasks, and above that you can implement the business logic into it. You can write multiple queries within a stored procedure. How does SP work? SP is a shorthand for stored procedure, and for coming lectures we are going to use the same instead of saying stored procedures all the time. Alright, so we were talking about how SP works. So basically at the back, when SP is executed for the first time, MySQL compiles the code of SP and stores it in cache memory and then executes the SP. And if this SP is invoked again, MySQL executes the SP from cache memory instead of recompiling it. MySQL can also have parameters which can be passed and the results can be sent back accordingly. SP can also call a different SP in it. We will be learning how to create SPs in our upcoming lectures. Now using SP has its own pros and cons. Here is the list of pros. First of all, the database security. With the use of SPs, we can grant privileges to SPs instead of directly giving any privileges to tables. So in a way, SP gives the ability to manipulate data instead of tables. For example, you have a customer table with no access and you just have access to SP, which gets the list of customers. So in that case, you will not be able to add or update or delete any records in customer table. Only you will be able to view the list of customer. That's it. Second, network traffic. Now SP's network traffic is reduced because instead of sending multiple queries to the server, you just have to send the name of SP with parameters. Reusable code. SP reduces the effort to write the same logic multiple places. Instead, we can have it at one place and use it at multiple places. Now let's talk about few cons as well. The first is increases load on server. As most of the operations are done on the server side, it increases the memory and CPU usage of the server. Debugging is another con. So unfortunately, there is no way to debug an SP in MySQL like we have in Oracle or MS SQL. Maintenance, again, it might require some specialized skills to maintain the SPs. Now let's talk about few relative questions. So the first question is, what is a stored procedure? The group of SQL statements that are stored in the server database is known as a stored procedure. The second question is, what are the advantages of stored procedure? So the logic applied in this application is centralized and is stored in the application. It can also be used as a security mechanism and they are used for reducing network traffic. Now in this lecture, we will learn how to list down the stored procedures in MySQL. So here is the basic syntax to list down the SPs using show procedure status. Let's execute this and this will show up all the procedures in MySQL with all the characteristics. Suppose we just want to list down the SPs of a particular database only, then we can use the where condition in this statement. I can say show procedure status where db is equal to Sakila. Let's execute and this will list down only the SPs for that database. We can also search for specific stored procedure names using the like operator. For example, I can say show procedure status like %not in %. Let's execute and here we see the result. We can also list down stored procedures from the information schema database, which has all the detailed information of SPs. So here is the query to do it. I can say select star from information schema routines where routine type is equal to procedure and routine schema is equal to Sakila. And let's execute and you see that all the procedures related to this database is displayed. Alright, so how do we create an SP, that is stored procedure? Now this syntax, let me just break it down. The first statement is delimiter $$. Basically, as we know that SP can consist of multiple SQL statements or business logics, so it is obvious that we might have multiple semicolons in it to break the statement. So to tell MySQL engine to compile the whole SP as a single statement, first we need to change the default delimiter to something else like dollar, slash, or maybe colon, etc. By default it is dollar, and by the way, we don't have to worry about it as it is recommended not to change. So here first line is change the default delimiter. Then we have create procedure, procedure name, and parentheses. So this is the statement which will create SP with the given name, and then in the parentheses we can have some parameters which we will learn in our upcoming lectures. After the create statement we have begin and $. So this is the place where we will write the actual query or business logic of the SP between begin and end. And in the end statement we will provide the delimiter sign so that MySQL knows that the SP ends here. And the last statement is delimiter semicolon, that is change the delimiter back to its original value. Alright, so let's create one SP which gets the list of customers with complete address details. Okay, so let me first write the basic query to fetch the customer data with address details. So select customer ID, I'll say concat first name, then I'm going to use the space and last name, full name, a.address, a.postal code, a.phone, a.district, ci.city, city.country, from customer alias C, left join address alias A on a.address ID equals c.address ID, left join city alias CI on ci.cityid equals a.cityid, and again a left join country alias city on city.countryid equals ci.countryid. Let's execute this and we have the result. Now let us create the SP and put this query in it. So let's write the delimiter first, delimiter $, and then create procedure and give the name of the procedure. Let's keep it as get customer list and parentheses. Then we will add the begin and end block. So begin and $, and delimiter semicolon. Now we paste this query between the begin and end block, and now select this whole query and execute. Alright, so the query is executed successfully. Let me refresh the schema and we can see here our newly created SP. Now whenever we want to get the list of customers, we just have to call this SP using the call statement, like call get customer list and then parentheses. Select and execute, and here is the result. Now let's talk about an assignment. So the assignment is create an SP to get the list of dates with day names for the current month, that is current month's calendar. So let's start. The first thing we need to do here is form a query to get the list of dates in the current month. So how do we do that? Okay, so the first thing is that we don't have any built-in function which can give us the list of all dates in a month. So we have to write some business logic to do that. So first thing is we need to get the numbers between 1 and 31. So either you can do a union starting from 0 to 31, like select 0 union, select 1 union, select 2 till 31, or other way is to create a number using cross join. How? So basically we know that a month consists of 30 or 31 days. So what we do here is we will create a table with 3 numbers. So select 0, first digit, union select 1, union select 2, union select 3. So if we execute this, it will give us something like this. and next we create another result with 0 to 9. So select 0 second digit, union select 1, union select 2 till union select 9. So now we have two different results, one with 0 to 3 and other with 0 to 9. And now we will do a cross join so that we get a combination of both the tables. So let me add here, I'll say select star from, and then in parentheses let me add the first query and give it an alias as A, and cross join, and in parentheses second query and give this an alias as B, and then order by first digit comma second digit. Let's execute, and now we have the combination of both the columns. So next is to form a number using these two columns. So we will write some expression. Now we know that we want only 2-digit numbers. So it's pretty simple. First digit into 10 plus second digit. Let me give this an alias as days, and let me execute, and expression will be more clear. So here is the result, and now we have numbers from 0 to 39. So we have some extra numbers as well, but that's okay. Now what next? We need to create a proper date using some date functions. So to create a customized date, we have built-in date function makeDate, which takes two parameters, that is year and day, like this. Select makeDate year, and there I just pass now and then comma 1. And you see that it returns us the first day of the year. Now we need to add 10 months to this date to get the current month. So to do that, we have to add 10 months to it. So plus, then we have interval keyword. So how much interval we need to add? So we want 10 months, that is interval and 10 month. We have the first day of the current month. Let me add the dynamic value in the interval instead of 10 so that it works for any month. So let me add here month now minus 1 instead of 10. So the month now will give us the number of the current month, and then we subtract by 1 to it. Alright, so we have a current month's first date, but we want this for the whole month. So now we need to add one more query. I'll say select star from. From what? From the query in which we have created a date. So in parentheses, we will add this whole query. And now instead of star, let me add here days and the makeDate function. Let's execute, and you see the result. But we have the same date in all the rows. So we need to change the date. To implement that, we will add here incremental day. So plus interval days day. So here days are the values of the column. That means it will increment by number of days in the column value, and day means it will increment the value by day. Let's execute and check now. And yes, here is the result that we want. Okay, also we need the day names, correct? So let me add one more outer query. Before that, let me add an alias to this as new date. Alright, now I will say select new date comma day name in the brackets new underscore date as new day from, and paste this query inside the parentheses and some alias. So here day name is a function which will return the day of the date passed in the parameter. Let me also add a where condition here, where month of new date is equal to month of now. Now let's execute, and here is the result we want. The next part is again very simple. $, create procedure, name it as get current month calendar, and just say begin $, and delimiter semicolon, and now paste this query inside the begin and end block and execute. Perfect. Now let's execute this SP using call statement. I'll say call get current month calendar. Let's execute, and superb. So we have successfully implemented the current month calendar. Now looking at this SP, you can make out that you have your own functionality inside the database named get current month calendar, which is a function normally not available in MySQL, but you made it and it can be utilized as and when required. So this is one of the advantage which you can see looking at this functionality, and you can make out how useful the stored procedures can be. Modifying SPs is a very common requirement in an enterprise level application. How can we do that? Let's see this practically. Unfortunately, we don't have any direct method to alter an SP. We have to drop the existing SP and recreate it. So first, we have to drop the existing SP using drop procedure if exists procedure name, and then again create a new SP. So whenever we want to alter or update an SP, I would recommend to use the IDE only. This will make your life much easier. Though the IDE will also drop and recreate the SP. Let me show you. So here in the stored procedure section, you will find the list of all SPs. So let us try to alter get customer list. Right click on the get customer list and then select the alter stored procedure option. So this will open the existing SP in a new query window. Here you can see that first it has the drop procedure statement, and then again it has create procedure statement. This definer section you don't have to worry much about. That is for administration and access rights purpose. If we want, we can remove this from here. And then we can make the changes between the begin and the end block. For example, let me remove this and write select star from film. Execute this. Perfect. And now when we call this SP, call get customer list and execute, it will return the film table. In this lecture, we are going to learn how to create SP with parameters. Most of the time you will find stored procedures with parameters. That's because having a stored procedure with parameters makes it more useful and reusable. We have two types of parameters which can be used in SPs, that is in parameter and out parameter. Let's check both of them one by one. So we start with the in parameter. Basically, in parameters are static values which, when defined in an SP, it has to be passed during an SP call. These parameters can be further used in the body of SP to manipulate the query or business logic. Let's check this example. Assume that we want to find customer details by customer ID. Let's check how do we do that. The basic syntax for create procedure will remain the same, delimiter $, then create procedure and name this as get customer details by ID, and then in parentheses we will add the parameters. So parameter type, that is in, then name of the parameter, let's keep it as customer ID, and then data type of the parameter. So let's keep it as int because we know that customer ID column in the table is integer data type, that is the int data type. And then begin, end, $, and delimiter semicolon, and in body select star from customer where customer ID equals parameter, that is customer ID. Here we can see that the column name and parameter name are the same, so in this case we should change the parameter name or else the result will not be as expected. Because even if we explicitly execute this query, it will be executed. That means this value is not treated as a parameter. Alright, let's change the parameter name. Then let me change this to pCustomerID. Now we can put this parameter in condition. Let's execute, and there we have the SP. Alright, let's call this SP. So I will say call get customer details by ID, and in parentheses we need to pass the value. Suppose we don't pass the parameter and try to execute, this will return an error. Now let us pass any customer ID and try to execute. Let's say 100 and execute. There we go. So here we have the customer with ID 100. Let's change this value and try it again. So now whenever we need to get details of any particular customer, we can use this SP. We can also declare multiple parameters in the stored procedure. So now let's check the out parameters also. So out parameters can be declared using the out keyword. Out parameters are basically temporary variables whose value can be changed or updated inside the SP, and then the variable is returned back to the SP. Let's check this example. So if we want to get the name of the customer by its ID, then this is how we do it. Here, instead of creating a new SP, let me alter the existing SP only. So I will alter get customer list by ID, and here in parameters I will declare one more parameter, that is out customer name data type variable character 20, and here inside the body I will add one more query, that is select first name into customer name from customer where customer ID equals p underscore customer ID and semicolon. Let's execute this SP. Alright, now let's call the SP. I'll say call get customer list by ID, and in parentheses pass the first parameter 100, comma, and second parameter. Okay, so here our second parameter is out parameter. So here we have to declare some variable using the @ sign, like @cname. Let's execute, and here is the result. But this is the result of the first query. What about the customer name that was queried in the SP? So the customer name has been returned in the cname variable. So I can say select @cname semicolon and execute, and here is the result. Now let's execute this together, and this gives you the result. Now let's talk about an assignment here. We have already created an SP to get the calendar for the current month. Let's extend that. So now instead of getting the current month's calendar, get the calendar for the month and year for which the date is passed, and also get the name of the day for the given date. So for this assignment, I will alter our existing sp, that is get current month calendar. Alter this and then I will declare in parameter. So in pdate and data type date, and for day name let me declare an out parameter. So out p day name and data type as Varchar 20. Next is we need to use this parameter in the body of sp. So where do we change it? In the query everything remains the same except the make date part. So here you can see that in make date in the year we have used now. So this will always return us the current date and month. So now instead of now I will use the parameter value that is passed in the sp. So let me change this now to p underscore date at all the places. And next we want to return the day name for the date that is passed in the parameter. So for that I will write one more query here. I'll say select day name and in parentheses p date into p underscore day name semicolon. Now execute this sp and we are done. Now let's call this and check. Call get current month calendar and let me pass some value because it's a date parameter. So I need to pass the value in YYYYMMDD format. So let me try 2022-0101 and for out parameter let me pass at day underscore name and also select at day underscore name. Let's execute and here we see the result. So we can see that now we have the calendar for January 2022. Let us change the value and check. Let's execute and there we go. What are variables in SP? Variables are temporary objects whose values can be changed inside the SP during its execution. Basically, this is used to hold immediate results and the scope of the variables are local to SP. To use the variables, first we have to declare it using the declare statement. Declaring a variable is very similar to adding a column in the table. To declare a variable, we use declare and then variable name with data type and default value. Let's see one example. Now we very well know the syntax of creating an SP. So let me quickly write a create procedure syntax here. Delimiter, create procedure and name. It is a variable test, begin, end, and again delimiter. Alright, now we are going to declare one variable here. Declare, let's name it customer count, data type B, integer and default value. Let's keep it 10. Now we can change the value of the variable using set command, like set customer count equals to 20, or we can set the variable using into clause, like select count star into customer count from customer and then return the variable using select customer count. Okay, let me return the variable here as well before assigning the new value to it. Select customer count. Now execute the query. Now let's call the SP and check. I'll say call variable test. So here we have the two result sets. The first result set is 10, which is the default value because we had returned the value right after the declaration. And the other result set is the one which we have returned after the second query. So in this, the value is updated by the customer count. So this is the basic concept of variables inside an SP. We will learn how to use variables in subsequent lectures. Now let's talk about questions. So what are variables inside SP? Variables are temporary objects whose value can be changed inside the SP during its execution. Basically, this is used to hold immediate results, and the scope of variables are local to that SP only. The second question is, how do we declare a variable? So this is the syntax, and that's how we declare the variable and we deal with the variables. Using if-else in SP. Basically, if statement has three forms, that is simple if statement, then we have if-else statement, and the last one we have is if-else statement. So if-else statement allows us to execute a set of SQL statements based on a specified condition. So basically, this can be used to write some business logic based on some condition. Let's check that out. So here we will be creating a procedure which will fetch the tables based on the table name provided. So let me create a procedure if-else test with in-parameter table name. And here in body, we will write the condition now. So first we will check the table name value using if statement. So I'll write if, and in parentheses I'll write the condition, that is parameter name. Here in our case it is table name equals to customer. So if this is the condition, then here we will write then, and now the select statement, select star from customer, and finally and if. That is the whole if block ends here. But what if I pass staff as parameter instead of customer? So this is anyway not going to execute, as we don't have any matching condition for this. So to fulfill that, we will add one more condition, that is else if. So before and if, we will add here else if and the condition, that is table name is equal to staff. Then select star from staff. We can add here many more else if conditions, like let me add here one more, else if table name is equal to film, then select star from film. Okay, that's cool. But now what if the value that is passed does not meet any condition? So for that we can add the else condition. Else is something you can consider as default. So let me write here else show tables. Now let's execute this SP. So the SP is created now, and let's call this SP using different parameters. I'll say call if else test customer. Let's execute, and it returns the customer table. Now let's change this to staff, and it returns the staff table here. And now if I pass any random value and execute, so this is going to execute else condition, that is we will have the list of tables. Alright, so we have learned about SPs in our previous lectures. Here in this lecture we will be learning functions, that is stored functions. So basically stored functions are a kind of program very similar to SPs, but can return only a single value. So you can use stored functions to encapsulate common formulas or business logic that can be reused. Also, the good part of stored functions are that they can be used directly in SQL statements. Like you can use stored functions in select statements, and that's because they return only single value rather than tables. The syntax to create stored function is also very similar to SP's. So here instead of procedure we have function keyword and the return type, that is what type of data this function is going to return. And finally in the body section, that is between begin and end, you have return value. Let's create one function and check. So assume that we want to find the total number of cities in a country along with the country details. So now we know that because both the country and city tables are different, and to achieve this we have to use joins and group by. So basically to achieve this we will have the query something like this. Alright, so how can we skip these joins? By creating a function. Let's create a function and check. So the first thing is the delimiter $$. Then we have create function name. Let the name be city count, and in parentheses let me add a parameter country ID, data type integer. And in function parameters we don't have anything like in or out. It's simply a parameter with data type. And now what this function is going to return? So it returns integer. So I'll say return integer, that is it is going to return the city count, and that value is the integer value. Now begin, end, $$ and delimiter. Now in the body section what do we write? We write a query to get the count of the city based on country ID. So let us do that. First we declare one variable here. So we'll say declare variable count. Let's name it v_count, data type integer and default 0. Now select count star into variable name, that is vCount, from city where country_ID is equal to parameter, that is country ID. And finally return this variable, return v_count. Now let's execute this and done. So now instead of using the joins we can simply write select star comma city count and in parentheses country_ID from country. Let's execute and here is the result. According to the theory, indexing is a data structure that improves the speed of operation in a table. And that is true, but that depends on what columns we are creating an index on. Practically, indexes are types of tables which keep a pointer to each record into the actual table. So in a layman terms, you can consider this as an index page in any book. Say for example, you have a book of 500 pages without an index page. And if you have to search one particular chapter in that book, you'll have to go through all the pages of that book until you find that chapter. But if you have the same book with the index page, then you can easily find the chapter from the index page and directly navigate to that page. Indexing in MySQL also works the same way. But you cannot see them. They are just used to speed up the queries. The theory also says that insert and updates are slower on tables having indexes, but that difference is almost unnoticeable. And anyways, insert and updates are not as frequent as fetching the data. Generally, there are three types of indexes which is widely used. The first one is primary key, which we know very well. The other one is unique index, and the last index is the regular index. We already know about primary key, So the primary key must have a unique value and cannot contain null value. Unique index is also similar to primary key, but it can have a combination of column values, and this can also have null values as well. And the last one, that is a regular index, is just an index. These columns do not need to be unique and can also contain null values. I think that's enough of the theory. Let's see how index helps us to improve the performance. Let's see what we can do with the tables that we have. Let's say we want to search for a customer named Kelly from a customer table. So let's query and check. I'll say select star from customer where first name is equal to Kelly. Let's execute, and we have 2 records. But how this query actually performed? How do we know that? So let's check that, and to check the explanation of query before this SQL statement, I will add explain keyword. Now let's execute the whole thing, and here we have some data. Just ignore all of these columns for now except this rows column. The value shown here is the number of records this query has searched to get the output. So it has searched 599 rows, that is the whole table. Alright, now let's create an index on the first name column and check. So to create index, the query is create index name. Let's say name it as IDX first name on table, that is customer, and then in parentheses column name, that is first name. Let's execute. Now once again check the explanation of this query, and now here in this column it says 2. This means that the query has searched only 2 records to display the output. Now if I add last name as well in the where query, like last name is equal to not, and check the explanation. So again it has searched for 2 records. Now this time let's create a unique index. So I will say create unique index. Index name, let's say IDX unique name on customer, and in parentheses I will add 2 columns, first name, comma, last name. Let's execute, and now once again let's check this. So here you can see that it has searched only 1 row. Also, creating unique index will restrict user to enter duplicate values for the combination of columns. Just say for example, in the customer table, if I try to enter the same first name and last name, it will throw a duplicate error. And if I try to enter some different value, it will execute it. So basically, unique key will always check for the combination of the columns provided in it. Alright, so this is just an idea of how indexing works, but that doesn't mean that we keep on creating index on all the columns. That's a very bad idea. Instead of an increase in performance, it may slow down your queries. Generally, while creating an index, we must take into consideration the size of the table, how many rows do we have, on what columns frequent joins or where conditions are going to get executed, and then decide whether to create an index or not. So basically, creating index on smaller tables or the table in which the query needs to perform some operation on all the rows, creating index makes no sense. Also, we can always use the explain statement to check what has been executed and decide on which table or column do we need to create an index. But again, that is just a data in real application. You are on your own to figure out what steps do we need to improve the performance. Don't be afraid to do some trial and error. In this lecture, we will be learning MySQL transactions and how to use rollback and commit transactions. So transaction in MySQL helps us to execute set of MySQL queries and ensures that the database never returns a result for a partial query. So if any of the statements fail, we can roll back the tables to its original state. In short, you are allowed to undo the job. It's a kind of undo. So transactions are very useful when we are dealing with master detail records. Let's first check one small example of how a transaction works. Alright, so to create a transaction, we'll first write start transaction. So now any query that is executed after this will not make the permanent changes in the database unless we commit it or roll back it. So after this, I will say delete from products. Before this, let us check the records that we have. So if I say delete from products where product ID is equal to 9, if I execute this without the start transaction, then this will delete the record from the table permanently, which cannot be rolled back, that is, cannot be undone. So let us execute this without transaction. Okay, now this says the record is deleted. Let us open one new session and check if the record is deleted or not. Let me open one more instance and query the product table. Here also we don't have the product ID 9. Let us move to this session and now let's execute this delete statement but with transaction. Let me change this ID to 8 and now we select both the queries and execute. Once again check the product table and here it's not showing the record with ID 8. Let's check the same in the other session as well. Execute and here the record still exists with ID 8. That means the final execution is still pending because we have started a transaction. Now either we can commit or roll back this. So if I say here roll back and execute, then check the table, we'll see that the deleted record is undone and the table is in its previous state now. And now instead of rollback, let's write commit and execute all these three statements. And now let's check the table. Now the record is deleted. Let's check this in the other session as well. So even here the record does not exist. So this is how the transaction works inside MySQL. Now let's talk about an assignment here. Create an SP to insert data into order master and order details using transactions. Alright, so here we need to create an SP to insert sales, that is order data. So we have to insert records into two tables. One is order master and using the order master ID, we will insert the record into the order details table. So first let us quickly create an SP which will insert records in both the tables. I'll write here delimiter $, create procedure transaction test, begin, end, $, and delimiter semicolon. And now here insert into orders, customer ID, order date, address ID, and the values will be, let's say 1, I'll say now, null. And then select last insert ID into @ID. So here we are storing the ID of the last record that was inserted. And now insert into order details. I'll say order ID, product ID, quantity and price, and the values are, I'll say @ID, that is the ID of order master table, comma 1, comma quantity be 10. So here we have intentionally not passed the price value just to check what happens to this record without transaction in place. Alright, now let's execute this, and now we will execute this SP called transaction test. And here it says column count does not match. That's correct. Now let's check the tables, orders and order details. So here the record has been inserted in orders table but not in order details table due to the error. So now we have an unwanted record in the order table which is meaningless because it does not have any related data in the details table, and this is also increasing the database size unnecessarily. So now here comes the transaction to rescue us. So now let's add the transaction in SP. So here before the query we will write start transaction, and after the query ends we will write commit. Alright, but this query has an error, so we need to roll back the transaction. So where shall we do it, and how do we check if there is any error? So here at the beginning we will write declare continue handler for SQL exception. So this is how we handle any exception in MySQL. So we have different handlers to catch different types of exceptions. Here we are creating a handler for any type of exception that occurs, so we have return SQL exception. Okay, then begin, end, and in between we will write rollback. So if any type of error is there in the SP, it will roll back the transactions. Let me also write some message. So here I'll say select, there is some error in the query message. And here after commit, select concat, and in the brackets I'll say last inserted order ID and whatever will be the value of ID, that is at ID, and the message. Now let's execute this and check. So here we can see the error message that we had given in rollback. And also check the records. So here the record is not inserted. Superb. Now let us correct this query and execute the SP. And once again call the SP, and now it says record inserted. Also check both the tables, and here is the record in the orders table and in the details table as well. Alright, now let's get started with MongoDB. Well, installing MongoDB on Windows is extremely simple. First, you have to open the official site, that is mongodb.com, and in that under products menu you will find community edition, and under this menu you will find community server. So clicking on this will take you to the download page. So here is the download section from where you can download different versions for different platforms. And here we will keep the current version and platform Windows, and let the package be MSI, that is executable file for Windows. Now click download. Once the file is downloaded, execute the MSI file and follow the on-screen steps. On product installation selection, click on complete installation. Just keep all the values as it is. Click on next and then wait for installation. So the installation is complete. Let's check the installed files. So here in Windows you will find the installation in C:/program files/MongoDB server 5.0 bin in this path. Here you will find mongod.exe and mongo.exe. MongoD is basically a daemon process for the MongoDB system. It generally handles data requests manages data access, and performs background management operations. Okay, so now to check it, we will first open command prompt. I'll type MongoDB. So this will start the server process. Here we can find that it is looking for some directory in c:/data/db. So this is the place where the data will be stored. So we have to create a folder in C drive as MongoDB is expecting, or we can create a folder at different location like we are doing here and then assign that directory path using this command. I'll say MongoDB --db path and your directory path. Here we have d:/mongo/data/db. That's what we have kept it. Okay, now once again run MongoDB and done. In case if there is some error which says command not found, you have to open environment variable and copy the installation path in the path key in user variables. Now open new terminal window and type Mongo and we are done. Let's check executing one simple command, show databases, that is show DBS. Let's press enter. So there it is, the list of databases. That means the installation is successful and we are good to go. Now let's talk about relative questions. So the first question is, what is the difference between MongoDB and Mongo files? So both are executable files, but MongoDB basically helps you to run the server, whereas Mongo actually runs the shell where you can type the commands. So that is the basic difference between MongoDB and Mongo. One is to run the server, the second is to run the shell. We will explain what shell is as we proceed further. The second question is, how will you change the database path? So basically, whenever it comes to changing the database path, you can use MongoDB utility with the --db path, and you can specify your own path, your own selection of the folder where Mongo will create the databases. So in MongoDB, creating a database is extremely simple. We just have to write the command, use database name, and you are done. But before we do so, first we have to start the MongoDB process. If we try to run Mongo without starting MongoDB, it will return us an error. So we are going to open the terminal and write MongoDB --db path and the path where we have created a data folder, and you have to do this every time. In case if we want to skip the assigning db path every time we run MongoDB command, we can create the folder to its default location. That is, for Windows it is c:/data/db, and you are done. Then we can simply start the MongoDB process just by writing MongoDB command. And now we open a new terminal and start Mongo by writing Mongo. That is, it starts the Mongo shell. Okay, it is connected now. Now let us create a database as nj_sampledb. And for that we will write use nj_sampledb and let's press enter. And here you see it says switched to nj_sampledb. That means the database has been created. Now to verify that, we will again write a command show dbs and press enter. But if you see, the database is not listed here. Now according to MongoDB documentation or rules, the database will only be listed if it has at least one collection, that is tables in terms of RDBMS. Common terms to remember in context to RDBMS: So for example, tables are known as collections, rows will be known as documents, and columns will be fields in MongoDB. Alright, now let us add one collection and check if the database is listed or not. So I will add one collection here. I'll say db.createCollection students and let's press enter, and now again show DBS, and superb. Now we have our database listed. One more thing to note here in MongoDB is that the commands in MongoDB are case sensitive, unlike MySQL, which is case insensitive. So in case if I write capital use like this, use new DB will return error. Now let's talk about relative questions. Here I just raise the question that compare the terminologies of RDBMS and the NoSQL MongoDB. What are the names for these in MySQL? So here is the answer. This we have already discussed. So table is a collection, row is a document, and column is a field inside the MongoDB with reference to RDBMS. In this lecture, we are discussing about how to create collection. So to create collections in MongoDB, we have the db.createCollection command, which has two parameters. The first parameter is the name of collection and the other one is optional parameter, in which we have some options that can be used to define the collection property. This is the basic syntax of create collection, where this part is totally optional. First, let us check which database is in use, and to do that we will write db and press enter. So the default database is in use here. Test is the default database which is used if we don't select any database. So let me select the nj sample db first. Let me write use nj sample db and then check again using the db command, and now we are good to go. Let us also check if we have any collections in this db or not. So to check that, we will write here show collections. Let's press enter, and we have one collection. Now let us create one collection named product. So we will write db.createCollection, and in parentheses inside the single or double quotes we will write product and enter. So there is no error, that means the collection is successfully created. Let's check again using show collections, and here is the collection that we just created. Alternatively, if we create any new document, MongoDB internally creates a new collection if the collection does not exist. For example, if I write db.dummyCollection.insert, in the brackets I put name colon some value, will also create a collection named dummy collection with the record. So now if we check show collections, here we can see that we have a collection named dummy collection. But this is not a recommended way to create a collection, because when doing this we cannot take advantage of optional parameters that we can have while using create collection command. So if we create a collection using db.createCollection, for example db.createCollection test collection, comma, and then in parentheses we can pass optional parameter like capped true. So basically capped collection here means fixed size collection. So if we are applying capped to true, then we have to specify the size parameter as well. So size parameter defines how much storage this collection is going to use, and the value here is to be specified in bytes. Once the collection is reached to its maximum size, it will remove the older document to make space for the new documents. We can also add max property, which will define the total number of documents, that is, records that this collection can hold. Well, generally capped collections can be useful for logs only, or if we have any specific use case to use it. So let us also create one capped collection and check. Here in this we have specific capped : true, size is 2 bytes and max is 2, that is 2 documents. Enter and done. Now let us add some documents to it. So I will write here db.testCollection.insert name document1 and enter, and let me add one more, change the name and enter. Okay, now let's check the records. So here I will write db.testCollection.find and enter. So we have records here. Now let me enter one more document. Let me also change the name to capped document and enter. And now when we check the records, we can see here that we have only 2 records and the record that was inserted first has been removed. Alright, so now let's talk about relative questions. So the question is, what is the purpose of create collection, or how can you create a collection? So basically we have the DB object which has a create collection method, and here is the syntax. You just have to give the name and you have few parameters like capped, size and max. You can utilize these parameters as we discussed, and this will actually create a collection in the database. We know that for any programming or scripting language or database, data types are very important. Now that we are already aware of table structured storage, that is the way data is stored in MySQL, but with MongoDB or any NoSQL database, the case is totally different. Nothing is stored in table format nor is retrieved in that way. Instead, the data stored in the MongoDB is in BSON format. It means the data which looks like JSON is not a JSON, it is BSON. Now what is this BSON? BSON stands for binary JSON. Basically, BSON is a superset of JSON which includes more advanced data types that are not present in JSON. That means MongoDB stores the collection in binary format, which is called binary JSON. Each BSON type has both integer and string identifiers as below. Before we start this lecture, I want you to download the latest version of MongoDB shell. Because when we start Mongo, there is a deprecation warning being displayed, so why not use the new shell? And you can download the new shell from the link given here. Once this is downloaded, follow the instructions and install. And now instead of Mongo, we have to write Mongo sh. So this seems little better. At least we know now in which database we are currently working. Alright, now in this lecture we will learn different options to insert a document. Well, MongoDB comes with two different types of documents. One is relational document and the other is embedded document. Mostly while working with MongoDB, I would recommend to go with embedded documents because that will help you to scale up the application without any hurdles. Now you have already learned about what RDBMS is and how it works. Relational documents work the same way, where you will have different documents for parent, child, and a reference of parent will be stored in the child document. Now, what is an embedded document? So an embedded document is one where you have parent and child values in the same document. Now, how exactly that works? Let us take a look into it. Let's recap these tables in MySQL, where we have relation between customer address and city, and because this is a relational database, each tables are joined with each other using some common ID. So how do we create this record in Mongo using embedded documents? Let's see that. So basically we have to create an object with key value pairs. To know more about objects, you can check my YouTube channel and also check my Udemy JavaScript tutorial. First, let us open a notepad and create an object. So to create an object, we need curly braces, and in between them, we will add the fields. So let us add the key here, that is name, colon, Mary Jane in single quotes. The rules to add the value will be the same as RDBMS or any other programming language, that is string and DateTime values to be written in single or double quotes and numeric values without any quotes. Now let us add some more fields: email colon some value, phone colon some value, and then address. Now in RDBMS, here in address we would have given the reference of the address table, but because we are creating an embedded document, here we are going to add address as an object itself. So address colon and then again curly braces, and in between some values like street colon value, zip code colon again some value, and city colon some value. So now this is our object or document that we are going to insert. So how do we insert this? The command to do this is db.collection_name.insert1, and in parentheses we will pass the whole object or object variable. Let us create one document now. Let me change the database to nj_sampledb, and to do that, I guess you already know, you say use nj_sampledb. Now let me add one variable here, const customer equals, and paste the whole value here from notepad. So before we paste, we have to remove the spaces and next line because Mongo does not understand the new line concept. So I just paste it, and finally we will write here db.customer.insert1 and in the brackets customer, and let's press enter. And now the document is inserted. Now let's check the record that is inserted. So let me write db.customer.find. Now here you can see that in the record it has some ID field. So what is this? We have not inserted this value. MongoDB always inserts this field when creating a document to make it unique. So basically you cannot ignore this, though this can be overwritten. If we provide an object with ID, it will create a document with that ID, else it will create its own object ID with some hexadecimal value. Quickly, let us try to insert one document with ID. Let me add ID with value here and enter. So now here we can see the inserted ID is the one that we had passed in the field. And now if we try to insert any document with the same ID, MongoDB will return a duplicate error. We can also do the same thing just by writing insert method, that is db.customer.insert, and then you put the customer. But this method is now deprecated as well. We will discuss ID related more information in forthcoming sections. Now let's talk about few relative questions. The question is, what is an embedded document? So an embedded document, as we discussed, is one where we have the parent and child values in the same document. And using the embedded document, you can scale up the application without any hurdles. The next question is, how do you insert a record in a collection? So here is the syntax. Like we try to insert the data, you just use the insert one. It is one of the syntax. There are other ways to insert, but this is one syntax where it inserts only one record in a collection. In this lecture, I will discuss about inserting bulk documents. And to do that, the command is db.collectionName.InsertMany method. And in this method, we have to pass an array of objects. So let's get started. First, we need to create an object array. So let me first open a notepad and create an array of objects. Well, it's not mandatory to create objects in Notepad, but I am doing this to make it a little easier and readable. Alright, so here is the object that we have already created in our previous lecture. So how do we create an array? This is how we do it. Open, close square brackets. This is an empty array. And now let us cut this object and paste this in between the brackets. And now this is an array of objects. I mean array of single objects. In fact, it is just the sample. Now let us copy this and add it a few times. Copy this and after this object put a comma and then paste it. Let's do this one more time and change the name in the objects. So let me change the name to James Bond, Ethan Hunt and Will Smith. Alright, now in the terminal, we will create a variable const clist equals and now paste this array. And then finally, we will write db.customer.InsertMany and in parentheses pass the variable that is clist and enter. So the records are inserted now. Here you have list of inserted records. Let's verify that. I'll say db.customer.find and there you see. So this is another way to insert a record, but this allows you to have bulk insertion. The question which I discuss here is how can you insert multiple records or bulk records? So this is how you do it, and certainly you need to have an array of objects that you need to pass inside the insert many method. Before we move forward in this lecture, we will load some sample databases for our further use cases in this series. So first we will navigate to mongodb.com and click on Start Free, which will take us to the registration page. Here you can register using email or with your Google account. Let me sign up with Google and then I accept and submit. And now you have to answer these few questions and click on Finish. Here on this page we will select the free version of Mongo and then click on Create Cluster. Now this will take some time to create. By that time, let us add some configuration. Here in the left panel, click on Database Access and create one new database user. So we are going to use the simplest method for now. So we will select the password option where we have to give some username and password and then add user. The password that we are providing here will be used to connect to this database from MongoDB shell. Next, click on Network Access and add IP address. For now, we don't want any restriction, so we will select here Allow access from anywhere and confirm. Once the setup is done, you will get something like this. Now click on ellipsis, that is these three dots, and click Load Sample Dataset. When this process is complete, it will connect this dataset using MongoDB shell. So now click on Connect, and from the list select Connect with MongoDB shell, and here we have to select I have the MongoDB shell installed. And now copy the connection string. You can also store this connection string somewhere for further use. Now open the command prompt or terminal and paste this, and let's press enter. Here it will prompt for a password, so you will have to provide the password that we had created earlier. Enter the password and press enter. So this is connected now. Let's check what we have now. Let me query here show databases, and there are plenty of sample databases for us. Let us check one. I'll say use sample mflix and then show collections, and we have good amount of collections as well. This will be of great use to learn MongoDB further. In this lecture, we will learn how to update a document. We have different methods to update the document. Let's go through these methods one by one. So to update a document, the command is db.collectionname.update, and in the brackets you have these three parameters, that is filter, update and options. First parameter is the condition for which we want to update the document, and then in the second parameter the fields that we want to update, and last one is optional parameter which can contain some configuration. So before we move ahead, let's check what do we have in the customer table. So I'll say db.customer.find. Now here we have few documents. So here we have a record with two documents with the name Mary Jane. Now let's try to update the email for these documents or records. So here I'll say db.customer.update, and inside the parentheses I will pass the parameters in the form of object. So the first parameter is condition, that is in curly brackets I will write the condition name colon Mary Jane, and then the next parameter, that is the fields that I want to update. So here I will put a comma and then again curly bracket and dollar set colon, and again in curly bracket I will write the fields that I want to update. Like here I want to update email, so I will write email colon updated email at gmail.com and enter. So here you can see the result, but what is this? In this result it says matched count and modified count is 1. But in the collection we have two documents with the name Mary Jane. So what about the other document? If we check the records using db.customer.find, we can see here that only the first document is updated. That's because the update function always updates the first document that is matched and exits. To update multiple documents that match the criteria, we have to pass the third parameter as an object in the function. So now in this function we put a comma here, and then inside the curly brackets I'll pass multi-true. So this will instruct MongoDB to update multiple documents that match the criteria. So let me just say enter, and now here we have matched count 2 and modified count 1 because the email of the first document was already updated by this email. Let us change the email and try once again. Let me change the email value and enter. Now the result says matched count 2 and modified count 2. Let's verify this, so I will say db.customer.find and here is the result. Alright, but this function is deprecated in Mongo shell. So now to perform these actions we have two other functions. The first one is db.customer.update1. So if I want to update only a single document, I can use db.customer.update1 and change the email. Now let's check the result so you can see the updated value. And if you want to update multiple documents, then you can use db.customer.updateMany. So here I will say update many, and instead of changing the value, let me add new field to it. I will say new email updated using update many. Instead, let me change the field name to remarks. Okay, now this makes more sense. Alright, enter, and there it says modified count 2. Let's check the updated document now. I'll say db.customer.find, and there we are. We have this remark field here for Mary Jane. So this is how we use the various methods for updating the document. Now let's talk about relative questions. So again, the newer methods, that is update one and update many, is often used nowadays. So what is the difference between update one and update many? As we have discussed, and the method name itself says that one method is to update one record and many basically is used for multiple records to update. In this lecture, I am explaining about how to query a document. To query a document, the basic syntax is db.collectionname.find. In the brackets, you have two parameters, that is condition and fields. First parameter here is the condition, that is based on this the documents will be filtered. This field is optional, so if we omit this, all the documents within the collection will be returned, or alternatively you can pass empty object. The second parameter in this command is projection, or fields that we want to include or exclude in the document. In context to RDBMS like this, where you have select and field names. Let's check out with some examples. So for this example, I will be using the sample database. Let me copy the server's connection string to connect. If you have not saved the key previously, you can refer to section loading sample dataset. Now let me change the database first. I'll say use sample_amflix and enter. The next step is check what all collections do we have here. So I will say show collections. Here is the list of collections that we have. So let us pick a movies collection for our example. Now I will write db.collectionname, that is movies.find, and press enter. So here we have some documents with tons of fields, and at the bottom it says type it for more. So this shell shows the first 20 documents, and when we type it will show the next set of 20 documents. Now if we want to find the documents with title 1 week, then here in parentheses I will write the condition in the form of object. So inside the curly brackets I will give the condition, that is I will write the field name title colon and value, that is 1 week. So this is equivalent to select star from movies where title is equal to 1 week. And now when I press enter, it is going to return the documents with the title 1 week, as you can see here in the output. But suppose we don't need all the columns here. We just want few columns to include or exclude. Then how do we do that? So there are two ways for that. Say for example, if I just want the cast and directors from the collection, then I will pass the fields that I want in the document. That is, I will put a comma here and pass the field names in array. Between the square brackets here, I will say cast and comma directors in single or double quotes. Now when I press enter, I have the list of documents with particular fields. So basically it is like select cast comma directors from movies where title is equal to 1 week. But here we can see that by default the ID field is included in the document. Now if we want to exclude this from the list, then here the second parameter has to be passed as an object. So here in curly brackets I will say ID colon false and enter. And here is the document without the field ID. Now here in the second parameter, except the ID field, we have to pass either the fields that we want to include or the fields that we want to exclude. That means if I write here cast colon false and then I say directors colon true and run, then it will say cannot do inclusion on field directors in exclusion projection. Or if I say cast true and directors false, then it will return cannot do exclusion on field directors in inclusion projection. That means here either we can pass only one projection, that is either we include the field or exclude the field except the ID field. That means ID can be set to true or false in any case. So this was just the basic idea of how to query a document. We will learn more about querying a document using different filters in our upcoming sessions. Now let's talk about relative questions. The first question is how to exclude ID fields from the document. To exclude ID field from the list, we have to specify the field name with true or false value in the second parameter. For example, here db.collectionName.find, then I give the query, comma, ID colon false or 0, and that will exclude the ID field. The second question is write a query to display the field's name and email from the comments collection. And for that, I'll write db.comments.find brackets, that is an empty object, comma ID is equal to 0, name 1 and email 1. In this lecture, we will learn how to query a document using different comparison operators. We have already learned the concept of comparison operators in RDBMS. Well, the concept is going to remain the same, only the change that we will see is the syntax, the way of writing the queries. So here is the list of comparison operators. Let's check one by one. Let's check the columns first in the movies document. So I'll say db.movies.find1. Now let's query on the runtime column. So let's say if we want to find the documents whose runtime is greater than 1000, then how do we do it? It's pretty simple. First, let's write the basic find command, that is db.movies.find, and in parentheses I will give the field name, that is runtime colon, and then again in parentheses I will give the operator $GT. that is greater than colon and value that is 1000 and enter. And here is the list of documents. Oh, so we have only 2 documents matching the criteria. But this seems a little difficult to read. So instead of displaying the whole document, let us select only specific fields. So for that we will put a comma here and add the fields in an array. So here it is runtime, and now when we execute this command, we have this. Now this is readable. In the same example, if we want to include the value 1000 as well, we will have to change the operator to $GTE, that is greater than equal to. And here we have the result according to this condition. Alright, so this is easy now. But what about nested fields? How do we provide the nested columns? To achieve this, we have to provide the column in dot notation. So it is like outer field dot inner field and so on. So say for example, if we want to query on a votes field which is nested inside IMDb, so how do we write it? Here we will write IMDb dot votes inside single or double quotes. So let me change the command. Here in place of runtime, I will write imdb.votes, and here in place of GTE, let me change the syntax to LT, that is less than, and change the value to 60. And here in columns also, I will write imdb.votes. Let's execute this and you see the result. And now in the same command, instead of LT, if I write LTE and execute, the result will also include the number 60, that is less than equal. Now let's talk about an assignment here. Write a query to find critic rating from movies collection using all the operators. Okay, so for this, first let us find the field critic rating. So I will say here db.movies.findOne. Here is the critic rating inside the nested object. Let's begin now. I will start with the basic command. I'll say db.movies.find, and in curly braces I will write tomatoes.critic and then .rating:9. Let me also provide only the particular field to display. Because we want to display critic rating, I will write tomatoes.critic.rating:1 and enter. So here we have the documents with critic rating 9. Now this command that we used is an equality operator. So basically it is select rating from movies where rating is equal to 9. Now let's use all other operators as well. For greater than, in the same command we will add curly brackets here after the field name and then give the operator, that is $GT:9 and enter. Here we can see the list of documents with rating greater than 9. Now in the same command, if we change $GT to GTE, it will give the records with rating greater than equals to 9. Now change this to $LT, that is less than, and check the result. And then if we change this LT to LTE, it will show us the documents less than equal to 9. What else now? Okay, so in case if we want to find the document which is not equal to 9, so what should we do? Simple. Change this LT operator to NE, that is not equal, and there we are. Isn't that simple? Alright, so here in this lecture we are going to see how to query a document with an array of values. The syntax for this will remain the same as we had seen in our previous lecture, querying document with comparison operators. Now what is going to change here is the operator. Let's take a look. Let's say, for example, if we want to find documents with title 1 week or a farewell to arms, then this is how we do it. The syntax here will be db.movies.find. In the brackets, I'm going to say field name, that is title colon curly brackets, and then the in operator, that is $in colon, and then the list of values in array that we need to query. So here in our case, we want to search the title 1 week or a farewell to arms. So here I will write square brackets, that is array, and in between this 1 week comma a farewell to arms. Okay, I will also put a comma here and give the field name as well, curly braces, title colon 1, and enter. Alright, so here is the list of documents with title 1 week and a farewell to arms. Now in the same command, if we replace $in with $NIN, that is not in operator, this will fetch all the documents where title is not equal to 1 week and a farewell arms. Let me change this to $NIN and enter, and here is the list of documents other than 1 week and a farewell to arms. Now let's talk about an assignment. So write a query to fetch documents where directors can be Buster Keaton or Joe May or King Vidor. So here is the query to achieve this. I'll simply say db.movies.find, opening the bracket, directors colon, again a bracket, $in colon, and now I'm going to open the square bracket, and I'm going to give the list, that is Buster Keaton, Joe May, and King Vidor, comma directors colon 1, and let's execute this query, and you see the result now. So far we have learned to query only a single field. Now in this lecture, we will learn how to query multiple fields using logical operators, that is the AND operator and the OR operator. Let's begin with the AND operator. AND operator performs a logical AND operation on an array of one or more expressions or conditions and returns all the documents that satisfy all the expressions in it. The syntax for using AND operator is something like this. Basically, you give the AND and you have multiple conditions, and when all the conditions satisfy, then the expression is valid, otherwise it is not. Let's check this into action. Let me first quickly check the fields. Let me give the command db.movies.find1. Now let us write a query to find documents where runtime is greater than 200 and rating is unrated. So I will say db.movies.find, and then in braces I will first write the operator, that is $and colon, and then I'll provide the conditions as an array. So I will put square brackets here, and in between them I will write the conditions. So the first condition is runtime should be greater than 200. Here we have to write the standard where condition syntax. That is, I will first put a curly bracket, and inside the bracket I will write field name, that is runtime colon, and then again curly bracket, and inside that $GT, that is greater than colon 200. So this is the first set of condition. And now I will write the second set. So I will put comma here, and again inside the curly bracket I will write the second condition, that is rated colon unrated. And now let me add the columns as well. So I will say here runtime colon 1 and rated colon 1. Finally, we are done writing the query. So basically this query is select runtime rated from movies where runtime greater than 200 and rated is equal to unrated. Seems like writing RDBMS query is much more simpler than NoSQL. Anyways, let's execute this, enter, and here is the result. So here we can see that all the documents have a runtime field greater than 200 and rated field is unrated. Alright, let's move on to the next operator, and that is OR operator. The OR operator performs a logical OR operation on an array of one or more expressions or conditions and returns all the documents that satisfy at least any one, that is any of the expression. So the syntax is the same. The only change is that in place of AND we have OR. So let's check this practically. I will use the same query that we used for AND condition, and in that let me change this AND to $OR and press enter. And now here we see the result that we have records where runtime is less than 200, and that's because the document satisfies the second criteria, that is rated is having unrated. So you see all the records where the runtime is 200 or the value in the rated field is unrated. Now let's check one assignment here. The assignment is write a query to get all the documents where IMDb rating is between 3 and 5 or 8 and 9. So let's begin. Let's check where is the field in the IMDb. So here is the field, and now to make this little easier, first I will write the command in the notepad so the formation can be little clear and understandable. So now I am writing the command to find the document between 3 and 5. That is db.movies.find, and in parentheses between the curly brackets I'll say $and colon and then provide the condition in array. So between the square brackets I will write an expression, that is imdb.rating, because rating is nested field inside IMDb object. So imdb.rating colon curly brackets $GT, that is greater than 3 and comma, copy this object and just change the operator, that is $LT, that is less than 5. Let me also add the field here. Now let's copy this and execute in MongoSH, that is Mongo shell. Before I copy this, I have to remove all these spaces. Alright, now copy this here and execute. And here is the result. The next step is we want to form a query which should be like rating between 3 and 5 or rating between 8 and 9. So how should we do this? Now $OR operator expects an array of criteria. So here inside curly brackets our main operator will be $OR, and this operator accepts the criteria in array. So I will put colon and empty array. Now I will move this object inside the array, and also I will copy this same object and paste it one more time and change the value here, that is $GT8 and LT9. So this is how the query is formed. This set of criteria is going to return the documents where rating is between 3 and 5, and this set will return documents between 8 and 9. And the whole query is wrapped inside the OR operator. So now this should return us documents between 3 and 5 or 8 and 9. Let's execute in the shell and check this. Okay, so here we have the documents between 8 and 9. Let's check if we can find any documents between 3 and 5. Let me type IT, that is it, here for the next set of documents, and here it is. So now this should give you a clear idea about how the and or operators work. Now in this lecture we will be learning a few more logical operators, which are $not and $nor. Let's begin with the not operator. Not is logical not operation which selects the document that does not match the operator expression. For example, the query which you see right now will return all the documents where a runtime field is less than equal to 10 or the runtime field does not exist. So now you might be wondering, instead of writing this query, we could have directly returned runtime $LTE, that is less than equal to 10. So what is the difference between these queries? Well, the difference is only that $not operator will find the documents even if the fields do not exist in the document, whereas $LTE will search the documents if the field exists and the value is less than equal to 10. Let's quickly check this. Here I will say db.movies.find runtime $not $GT 10 runtime 1 and enter. So here we can see that we have the records where runtime is less than equal to 10, and also we have the documents where the field is not present in the document. And now we will try to query the same using the LTE operator and check the difference. So let me quickly write the query where I will say db.movies.find, and instead of not I'll say LTE and enter. Now here we have only the documents where the field exists and is matching the criteria. Alright, so the next operator that we will see is the NOR operator. So basically the functionality of NOR is the same as NOT, but NOR performs operations on an array of query expressions. For example, this query will return us the document which contain the runtime field and is less than equal to 10, and also contain type field whose value is not equal to series, or contain the runtime field whose value is less than equal to 10 but do not contain the type field, or do not contain the runtime field but contain the type field whose value is not equal to series, or do not contain runtime and type field. So let's check this. Let me write the query here, db.movies.find, and in parentheses curly brackets I will write $nor and provide the condition expression inside an array. So the first expression I will write here is runtime $GT 10, and next expression is type series. Alright, so now let's execute, and here is the output, that is you see the documents filtered. Now let's discuss an assignment here. The assignment is write a query to find movies where IMDb rating is greater than 5 and votes are less than 5,000. Now because we have multiple query expressions involved here, we are going to use $NOR operator. So I will write here db.movies.find, and inside the braces I will write $NOR : and inside the array we will write an expression. So the first thing that we want is IMDb rating greater than 5. So here in the braces I will write IMDb dot rating : and again inside the braces $LT, that is less than 5. So the whole query is like not less than 5. And then the next expression, that is votes should be less than 5,000. So here I'll say IMDb dot votes : $GT 5,000, that is not greater than 5,000. Also add the columns here, IMDb dot rating and IMDb dot votes. Now let's press enter, and here is the list of documents as desired. So this is the answer for the assignment. In this lecture, we will learn how to limit number of records. Limiting records will be helpful only when used with a proper application and some programming languages, because MongoSH shell displays only the first 20 records. Anyway, that doesn't matter. What matters is we will learn how to limit records in MongoDB. So basically it's very simple to limit the records. We have a limit function. So after the standard find command, we have to use the limit function. Let's take a look. Here I'll say db.movies.find all the records and filter, and then comma braces title : 1, that is we just want to display title column. And then after the parentheses we will write dot limit parentheses, and here we will write some number. Now here if we don't give any number, it will return all the documents. So here let's write 5, that is we want to get only 5 records. Let's press enter, and there we are with only 5 records. Let's try one more. Let's display 25 records and press enter. So now this is showing us first 20 records, and then it says type IT for more. And now when we type IT, that is it shows only 5 records. That's because we have limited the query to show only 25 records. Now in this command we can also use the skip function to skip the rows, that is offset. For example, if we want to skip the first 2 records from the document and then start the search, then this is how we do it. Before that, let me query only 5 records, and now check these documents. We are going to skip the first 3 documents, so our list of documents should start from cops. Alright, now in this same command, after the limit clause, I will write here dot skip parentheses and number of documents to skip. So here we want to skip 3 records, so I will say 3. Let's enter, and there we see the documents starting from the cops. Now let's talk about relative questions. So the first question is, what is the use of limit command? The limit command is used to limit the number of documents to fetch in the list. The second question is, can we use skip command without a limit command? Well, of course yes. So I can directly write db.movies.find.skip and 2. This will actually skip 2 documents. In this lecture, we will learn how to sort documents, and to do that, we have a sort method. So it's like db.movies.find.sort, and inside the sort function, we need to pass the field name in curly brackets with the value 1 or -1, where 1 is for ascending and -1 is for descending. Let's check this. If I write here db.movies.find.sort without any parameters in the sort function, then this will sort the documents by its key, that is the object ID, in ascending order. Let me add only the title column here, and then I will say enter. So here is the result. This result doesn't seem to be very clear. Let's try some other fields. So I say db.movies.find, giving an empty object, comma, runtime:1, dot sort, and in curly brackets, runtime -1, that is, we are sorting the documents by runtime field in descending order. And there we are. Now let's try ascending order. So in this command, instead of -1, I will write 1 and press enter, and you see the result. But in ascending order, first this is showing the documents which do not have the runtime field. Let's do one thing. Let's query the document in which the runtime field exists. So how do we do that? Well, to do that, we have the $exists command. So I will write db.movies.find, and in curly brackets, I will write runtime: curly brackets, and then $exists: true, and then .sort runtime 1. Now let me press enter. So now we have the documents which have the runtime field and are sorted in ascending order. Now let's talk about a relative question. So the question is, what is the default sort direction of the sort method, and how do you change that? Well, by default, the sort method will sort the documents in ascending order, and if no parameters or fields are provided in the method, then by default the sorting will be done on key field, that is object ID. And if you want to sort the data in descending order, you're going to give -1 like this, and that will give you the result in descending order. Now let's talk about aggregate command, count. The count function will return the number of documents in the collection based on some condition if provided. Let's find out the total number of documents in the movie collection. So I'll say db.movies.count and empty parentheses and enter. And here it shows the total number of documents. But this count function is deprecated and will be removed in future release. So the newer function to this is countDocuments. So instead of count, I will write db.movies.countDocuments. Now let's try to get the document count based on some condition. Let me quickly check the fields. I'll say db.movies.find1. Let's count the documents based on year. So here I will say db.movies.countDocuments, and now inside the parentheses I will write the condition. The condition would be inside the curly brackets field name, that is year, value, that is 1903, and enter. Well, only one. Let's try some other year. Let's say 2000. And here we have 618 documents where year is 2000. Now let's discuss an assignment. So write a query to get count of documents where type is series and IMDb rating is between 2 and 5. So I will say db.movies.countDocuments, and now in parentheses let's write the condition to get documents between 2 and 5. So to achieve this we need to use $and operator here. So I will write $and colon and the condition in array. So the first would be imdb.rating colon brackets $GT, that is greater than 2, and then comma imdb.rating colon $LT, that is less than 5, and enter. So here we have 1277 documents. Now in this we will include the second condition, that is type should be series. So to do this I have to add one more $and operator, and at the beginning I will add $and colon, open the array, curly brackets, and now this whole condition will become our first expression, and here I will close these brackets and array, and now comma curly brackets type colon series. So basically the query is where IMDb rating greater than 2 and IMDb rating less than 5 and type is equal to series. So here this condition IMDb rating greater than 2 and less than 5 as a whole becomes our first set of expression, and then this whole condition IMDb rating greater than 2 and less than 5 and type is equal to series is our final query. Alright, so let's press enter, and here we see that we have the proper result. Same result can also be achieved using the count function, which is anyway deprecated. Distinct function is used to retrieve the unique values from the collection and will return the value in the array. Let's say, for example, if we want to find all the possible types of movies in the collection, that is all the unique values in the type field. So we will use the distinct function here. I will say db.collection.name, that is movies.distinct, and inside the parentheses name of the field for which I want the unique values. So I'll write type because I want to find the distinct values for the type field. So here is the list of unique values. So we have two types of movies in the collection, that is movie and series. Let's try another field where we can have some more values. Let's check the rated field. So here I will change this to rated and enter. And here we have the list of distinct values again. Alright, now we will try to get distinct values based on some condition. Let's say, for example, if I want to find the distinct rated field where the year of the movies is greater than 2000. So I'll say db.movies.distinct rated, and here I will add a second parameter as a condition. So I will put a comma here and then the condition, that is curly brackets year colon curly brackets $GT colon 2000 and enter. And here we have list of movies where we have distinct rated field and year greater than 2000. Now let's check one assignment. The assignment is write a query to get distinct value from the rated field where IMDb rating is between 3 and 5. And the query will be db.movies.distinct rated comma curly brackets then $and array and the condition, that is imdb.rating colon $GT 3 comma imdb.rating $LT 5, that is less than 5, And let's press enter, and here is the answer for the query. Aggregate functions here is used to process the documents and return the result as combined output. So here basically we are talking about commands like max, min, average, sum. So here aggregate is similar to count function but with group by functionality. Let's check some examples. Let's find out the different types of movies and their total count. So what we are doing here is we are counting the total number of documents grouped by type. First, I will write db.movies.aggregate parentheses, and then I will put an empty array, and then inside the array I will create an object that is curly brackets and then $group : object. So now what are we supposed to group? We want to group type field. So here I will say _ID : and the field name in quotes prefixed by $, that is $type. Alright, let's execute this. So now here we see two records. Let's add some value to this. So here I will count the total number of movies. In this group object, I will put a comma here, and now let's add a field name total _ movies brackets and then aggregate function name, that is $sum : 1. So here $1 means that it will count each document as 1 and then will total it. Let's press enter, and here it is. So basically $sum : 1 is similar to count function, but instead of 1 we can provide a field name here to sum the field value. For example, if I write here $runtime, this will sum all the values in the runtime field, and you see the result. Alright, so now we can add here more aggregate functions like average, max, and min. So for example, instead of $sum, if I write here $avg, then this will average the runtime field. Let me change the field name as well, so I will change this to avg _ runtime. And now we have the average values. Now let's extend this little more. If you want to add condition, then you have to add the condition at the beginning. For example, the condition is our first parameter in the aggregate function. Here at the beginning I will write brackets, and in that $match : and the condition, that is in brackets year : 2000, and now enter. So here we can see the average runtime for different types of movies for year 2000. Here the sequence also matters. So in case if I write this match condition as the second parameter, then this is not going to show us the expected output. Now let's talk about an assignment. Write a query to find aggregate values total, average, minimum, grouped by year and type. Let's start this now. I'll say db.movies.aggregate, and inside parentheses we put an array, and let's create a group object. So I will add curly brackets and $group : brackets and the field name to the group. So I will write _ID : alias name. So I will give here year : and the actual field name prefixed with $. So it is $year, and now same way we will add the other group field, that is type. So comma type : $type. Alright, now let's add the aggregate values. So first I will write total _ movies : $sum : 1. Now let's press enter and see the result. So we have something here, but the result is not very clear. Let's do one thing. Let us add one condition here. So here at the beginning, I will add a bracket and $match colon brackets and add the condition year colon 2003 and press enter. So now it's clear. Here we have a total of 646 documents in 2003 whose type was movie and 10 documents whose type was series. Now add other aggregate values as well. So here I will add one more alias, average underscore runtime colon brackets, and the aggregate name, that is $avg average colon and the name of the field $runtime. That's it. Let's press enter. And now let us add here min and max as well. Let me copy and paste this and change the value to min underscore runtime and $avg to $min. And let me paste in one more time and change this to max underscore runtime and average to max. And let's press enter. The result which you see is the answer to the query. MongoDB returns the date either as string or date object. The date function returns the current date as a string in Mongo shell, whereas the new date function returns the current date as a date object in UTC format. There are various ways in which we can specify the date format. For example, this will return us date in string format in current time zone. Next is new date. This will return date as date object in UTC. Then we can also pass date like new date and in parentheses milliseconds, which will return some date in UTC format. Next we can pass a date string in the date function in the 4y mmdd format. Oops, missed the closing tag. In 4y mmdd HHMMSS, that is R minutes seconds, we can also use the ISO date function instead of new date. This will also return us a date object in UTC time. So basically this is the same as a JavaScript date function. Now let's see one example of how to use date in a query. Let's say, for example, we want to get all the documents greater than a particular date. Then this is how we query. db.movies.find field name, that is tomatoes.last updated colon parentheses greater than colon, and now the date function, that is new date, for example 2015-0101. Let me add the field value here and enter. So here is the result. Also, let's do a quick assignment. Write a query to get documents between 11th September 2015 and 13th September 2015. Here we need to compare two dates. So what operator are we going to use? Correct, $and operator. So the query would be db.movies.find brackets $and colon array field name, that is tomatoes.last updated colon brackets $gt colon new date, and the date is 4y's mmdd format, that is 2015-09-11, comma, and one more time tomatoes.last updated colon brackets $lt colon new date 2015-09-13. and also add the field name here. And now let's press enter. So here we see the result. You can see that though we have used greater than operator, then also it is listing the document of date 11. And why is it so? That's because the date will compare the whole date object, that is including the time values. So in that case, because we have provided only date part in date function, so it will compare only the date portion. Basically, the values should be greater than 2015 09 11 and also the time segment, that is 000000. There is also a question that difference between date and new date. So the date function will return the date in the current time zone in string format, whereas the new date function will return the date in UTC time zone and as an object. Now let's talk about the regular expression, that is the $regex operator. Here in MongoDB also we have the regex operator, which identifies the pattern in the document. Well, regular expressions are one of the most widely used tools in programming related to strings. That means that every string can be connected in a way through a pattern, and these patterns can be recognized and used to boost search for string data values. If you really want to know absolute details of regular expression, then I have a dedicated JavaScript and regular expression course which can guide you and which can show you things which you may not have seen with regular expression. You can check this tutorial for further details. We have already used the patterns in MySQL query section. So here is the quick recap of some patterns we have used previously. Let's quickly check some of these in action. So to use this, we have the $regex operator. So let's begin. The basic find query would be the same. I will say here db.movies.find title colon and then in brackets $regex operator, that is $regex colon and then the pattern we will write between these two slash. So let's say if I write here test, that means this is going to find test keyword anywhere in the title field. Let's press enter and you see the result. And here in the result you can see that it is also showing the result for fastest keyword as well because of the test in it. Now let's say in this command if I add a caret sign, then this will search for the documents whose title is starting with test, and also this is case sensitive. Let's press enter and no result. This means we don't have any title starting with a test. Let's try to search the same result but with case insensitive, and to do that we will write I here after the slash, that is case insensitive or ignore the case. Let's press enter and here we have some results like test, pilot, testament, etc. Let's check one more. If we want to add multiple expressions, then we can do that using pipe as a separator. So if I write here pipe and then black $, so this expression means either the title should start with test or end with black. And now you see the results. Okay, now let's talk about an assignment. Write a query to find the documents where the title should start from a letter between A to F and should contain exactly 4 letters. So I'll say db.movies.find title $regex colon, and now let's write an expression between these slashes. So our name should start with A to F, and for that I will add a caret sign first to match the beginning of the string, and then the character should be between A and F, and for that I will add a square bracket and give the range of letters. So I write A-F. Let me also write I here for case insensitive and also the field name here. So now if I execute, this will get all the records which are starting with A, B, C, D, E or F. But we want to find the names which are of exactly 4 characters. So now in this expression after the square brackets, I will put a dot, that is it will match any single character, and this we want to repeat for 3 times. So we put a curly bracket and write 3. And then we end the string after 3 characters. So I'll put a $sign. Let's execute this. And here are the documents with exactly 4 characters and starting with letter A to F. Index is one of the important part of a database as it is responsible for making the database efficient. By default, MongoDB implements indexing on the _ID field. So every time we create a collection, an index is created on ID field and this index cannot be dropped. Indexing helps to improve the speed of search operations as the search will be carried upon indexes that carry few fields instead of traditionally searching the whole document. The syntax to create an index is db.collectionName.createIndex, and inside the createIndex method we have to pass the field name on which we want to create an index followed by 1 or -1, where 1 is ascending order and -1 is descending order. That is how we want the index to be implemented. Alright, let's create some indexes here. Let us check if we have any indexes created in movies collection. So I will write db.collectionName, that is movies, dot get indexes, parentheses and enter. So we have 2 indexes. One is on the ID field and the other one is on the _FTS and FTSX field. Now I will create one index on the year field. So I will write db.movies.createIndex, parentheses, and inside the curly brackets I will provide the field name, that is year : 1 and then comma second curly bracket, and I will write IDX _year. So IDX year will be the name of the index. Enter, and no error. Let's check if the index is created or not. So once again I will write db.movies.getIndexes, and here is the index that we have created. So the index that we created now is a single field index. Same way we can create a multi-field index. Let's say for example I want to create an index on type and title fields. Then this is how I do it. db.movies.createIndex, and in brackets I will write type : 1, title : 1, and now let's give it a name. So I will write name : IDX _type _title, and enter. And now let's check again the indexes. So here we have it. Alright, let me create new collection here now. I'll say db.createCollection, let's say my collection. Now let's check the indexes. So here we have the default index created on ID field along with the collection name. Now let's try to create one unique key index. So I will say db.mycollection.createIndex brackets and name : 1, email : 1. Name it as IDX underscore name underscore email, comma, and unique colon true. That is, these fields will always have unique values. Now let's press enter. Let's try to insert some values. So I will say db.mycollection.insertMany and name John and email john@gmail.com, and add one more object in which again I will give the name as John and email j@j.com. Let's enter, and here we have two records inserted. Let's check db.mycollection.find, and yes, we have two records. Now let's try to insert one more record with the same name and email. So I'll say db.mycollection.insert1 and name is John and email j@j.com. Now MongoDB throws a duplicate error because of this unique key index that we have created. We also have one more option, that is sparse. So if we provide a sparse option, that means the index will be created only on the documents in which the field exists. So this is how we create it. I'll say db.mycollection.createIndex name :1 and sparse :1 and enter. And finally, now let's check all the indexes that we created in my collection. So I will say here db.mycollection.getIndexes, and you see that we have list of indexes created. Now that you know the database concepts well, you must also know some important must-know concepts, or we can say terminologies about databases. This section covers the theoretical part of database concepts with topics like what is RDBMS, SQL, NoSQL, what's the difference between SQL, NoSQL, which one should you choose, etc. If you know these concepts well, it will add more weightage to your experience. You can present your candidature in a better way when you are facing interviews or real-world situations related to databases. Do make sure to go through this section to know the basic concepts in databases and what kind of questions are asked in interviews related to them. You might be knowing a lot of practical things, but when it comes to discussion, when it comes to talking, it really is important that you know this section very well. In this lecture, I am discussing about the DBMS or RDBMS, its categories and how it works. In any application, there is a large amount of data and information, some stored by the developer and some collected from the user. Any application works based on the data. This data needs to be stored somewhere so that we can access and manipulate it as and when required. And for this purpose, we use databases that are used to store the data and can be accessed using the software application known as the Database Management System, DBMS. It can be considered as the collection of databases. We can connect to a DBMS or database for accessing or manipulating the data by writing queries and commands. There are two categories of databases. One is the relational DBMS or RDBMS, and the other is NoSQL, or sometimes known as NoSQL. Let us first talk about RDBMS here. In RDBMS, the data is stored in the form of tables, that is in a row and column structure. This collection of tables is called a database, and all such different databases are combined to form a DBMS. Here the databases and the data tables are interrelated, so it is said to be relational DBMS. Let me explain you with this example. Consider this table to store employee data, which is formed with rows and columns. Now a smaller entity than table is a field. A field specifies what data is stored in the table, like here these are the fields: employee ID, employee name, department, salary, etc. And when we enter any data, it is known as a record. This is a row record and this is a column record. If any field of the table is blank, it specifies the null value. And because of this relational model of the DBMS, it is known as RDBMS. Relational database management system has its own ways to validate for unique data or checks for user-defined data validations. One can do data manipulation, that is adding, removing, updating data with the help of a query language, SQL, that is the structured query language, which is the language used to work with RDBMSs. SQL is an extremely powerful yet simple English-like query language which gives you complete control to deal with the database. Now let us have a look at few RDBMS databases with their official sites. We have the MySQL, which we are going to learn. We have Oracle, a very old and prominent product. Then we have Microsoft SQL Server, also known as MS SQL Server. We have IBM DB2, Postgres, then MariaDB, etc., among which we are going to learn MySQL for RDBMS in our tutorial. Let's talk about few questions. The first question is, what is a database and what is DBMS? A database is a collection of data and information stored in the form of tables, and all such databases come together to form an organized collection of databases known as a DBMS, that is Database Management System. The second question is, when can any DBMS be called as RDBMS? When various tables and databases have interrelationship among each other, it forms a relational database model known as an RDBMS. The relation is based on the meaningful data relativity of the data stored. The third question is, how does the RDBMS store the data? So the data is stored in tables, and the tables have rows and columns. We have the individual field for the piece of data. Collection of field in the horizontal manner is the row or a record. And when you say a column, that shows you all the values of a single field. Like for example, here we have the employee name. If you see this column, it shows you all the employee names, and that is the field name. That is, employee name is the column name or field name. But if you consider this as horizontal, we have employee ID, employee name, department, salary. So this gives you all the details of an employee. That becomes a record, that is a row. The fourth question is, which language is used to work with RDBMS? That is, to deal with, to manipulate the database. Which language is used? So it is the SQL, that is the structured query language, which helps you to manipulate or deal with the database management systems. When we say NoSQL database, we typically use it to refer a non-relational database. Some say NoSQL stands for non-SQL, while some say it stands for not only SQL. Just to emphasize that they might support SQL-like query. Either way, we all agree to the fact that NoSQL are non-tabular databases that store data in a non-traditional way, that is, rows and columns. Now when I say traditional, that means data stored in row-column format. Over the period of time, 4 major types of NoSQL database have emerged. The first is document type. This is the most used type of database when it comes to NoSQL. This type of database stores the data in a document similar to a JSON object. The second is key value pair. Now this stores data in form of key value pair only. So you have the field name and the value, that is the key and the value. The third is wide column stores, which stores data in tables, rows and dynamic columns. And the last one is graph database, which stores data in nodes and edges. Typically, node stores information about places, people, and things, while edges store the data of relationship between nodes. The main benefit or the reason that I see to use NoSQL is its flexibility. NoSQL gives developers more freedom, speed, and flexibility to change both schema and queries to adapt the ongoing data requirements. The other main benefit is it has the ability to scale out horizontally or add less expensive servers. Another benefit is faster queries. Generally, RDBMS databases are typically normalized, so to fetch queries for a single object, we need to join multiple tables. And as tables grow in size, join can become expensive. But in NoSQL, data is stored in a way that is optimized for queries. So basically, the thumb rule of NoSQL is data that is accessed together has to be stored together. So queries typically do not require join. So now the question that comes to your mind is, what is this horizontal and vertical scaling? So to be very quick, horizontal scaling means adding more processing units, that is replicas of the same physical system, while vertical scaling means adding more processors, that is RAM or CPU. Let's discuss few questions here. So what is a NoSQL database? So NoSQL, NoSQL are the databases that store data in format other than the relational tables. The second question is, what language is used to query NoSQL? Well, NoSQL has a variety of types and implementations. So NoSQL can be queried using a variety of query languages and APIs. MongoDB is one of the most popular NoSQL database and can be queried using the MongoDB query language. The third question is, does NoSQL have schema? Well, NoSQL has a flexible schema, but some NoSQL databases like Mongo have support for schema validations. There are additional drivers, additional support libraries which allow you to implement the schema-based database. So let's discuss what is SQL, the purpose, and how it works. Some people say SQL and some people also pronounce it as SQL. But actually SQL is a trademark of a UK-based Dynamic Engineering Limited company, which is mentioned on Wikipedia. So one should not call it SQL, though developers still use this term. The SQL acronym stands for Structured Query Language, a standard language used for accessing and handling the Relational Database Management System, that is RDBMS. So cutting it short, with the help of SQL, we can insert, that is add, retrieve, manipulate and delete the data from a table using queries. The SQL command, commonly called query, and it looks something like this. Say for example, select star from employee, which means the query is fired to select, that is to fetch all the data stored in the employee table. As I mentioned earlier, that SQL commands are English-like statements. It is not a case-sensitive language and the keywords in SQL are often written in uppercase. Because SQL is used to perform various operations on data and tables in a database, there are few categories of the SQL commands as per the action they perform. For example, the commands that are used to change the structure of a table, like create, drop, that is delete, alter and truncate a table, are called DDL, that is data definition language. DDL specifically changes the table structure and permanently saves the changes. The commands to manipulate or modify the database are insert, update, delete, and are called data manipulation language or DML commands. The next category of commands is to grant or to deny the authority to a user is called the data control language, that is DCL commands, which are grant and revoke. The commands that are used to control the data manipulation transactions, that is they can work only with DML commands, are called transaction control language, that is TCL commands like commit, rollback, save point. And the select query that we saw in the example is called a data query language, that is DQL command used to fetch the data. DQL uses only the select command. So SQL uses these commands to access and manipulate tables and databases. We will practically use these commands as we start working with the MySQL database. In the next section, we will install and configure the MySQL. Let us see few relative questions. So the first question is, what is SQL? What is the syntax? Well, syntax is very simple. You just use the English like language, like selecting means select star from table name. When you want to delete something, then you have delete. When you want to update the data, you have the update query. That's how it goes. So the syntax varies, but it is very simple to understand. The second question is, how many types of SQL commands are there and what is their purpose? We have already discussed that SQL uses these commands to access and manipulate tables and databases. Well, nowadays the market is abuzz with terms like NoSQL, big data, database appliance, etc. Often we get very confused about decision making with all the noise. It becomes difficult. Why should we consider a newer alternative database when RDBMSs have been around for 20 plus years? However, many leading enterprises are already using alternative databases and are saving money, innovating more quickly, and completing projects they could not pursue before. We have seen that in many years RDBMS has been doing the job for us, and it's not that they are not compatible, but yes, it has some cost. But now when you have a variety of data types and have a large store of data that is expected to grow and cannot afford downtime, there is a good chance that a NoSQL database is the right choice. Because in RDBMS we have to foresee the future and plan our schema accordingly so that there are less changes in the future. It's not that changing schema is difficult in RDBMS, but yes, it can cause serious impact in operations if not done rightly. And as the data grows, performance is one big issue as many joins are involved in queries. Though this can be overcome by indexes, that requires good skills, and upgrading of high performance servers come at a very high cost. On the other hand, NoSQL databases are totally flexible and the data stored are in newer formats, that is JSON or BSON. BSON is an extended version of JSON, which is actually the binary JSON, which most of the programming languages understand. And as everything is stored in the same entity, the lookup is really fast. For example, if I want to store data of a person with its address, then in RDBMS we'll have this kind of structure. We'll have customer table and address table joined by some common value, and to retrieve that we will be using joins. Where on the other hand, in NoSQL, we'll have a single object, something like this. So to fetch this kind of data, we don't require any join. So now what to choose and when? Well, RDBMS is still the best choice when we need to ensure ACID compliance, that is atomicity, consistency, isolation, and durability. ACID compliance reduces anomalies and protects the integrity of our database by prescribing exactly how transactions interact with the databases. Generally, NoSQL databases sacrifice ACID compliance for flexibility and processing speed. When we know that data is structured and has no or minimal change, then RDBMS is the database that should be selected. For example, ERP, accounting, financial things, etc. Now, when you have to store large volumes of data which have little or no structure, then NoSQL database is the choice. With a document-based database, we can store data in place without having to define data types in advance. Example, e-commerce app, multiplayer game, social network, fraud detection system, etc. Let us have a quick comparison between both types of databases. The first thing is the data structure, where RDBMS is static and rigid with predefined schema, focuses on normalization and alleviating data redundancy, whereas NoSQL databases have dynamic and flexible schemas that handle all types of data, including structured, semi-structured, or even unstructured and polymorphic. The second is scalability and cost. SQL is better fit when data is fairly static and you don't expect much growth. It is possible to horizontally scale a SQL database, but it requires additional coding, substantial effort, and it's expensive. Whereas NoSQL, it scales horizontally, so you can easily and more economically expand capacity simply by adding commodity servers or cloud instances, more cost effective and good fit for cloud computing. The next point is availability and resilience. Here, high to moderate application availability. SQL databases are often hosted on one server, whereas here, continuous availability, zero downtime, no single points of failure. Then comes the ability to query. The SQL language is easy to learn and queries can be conducted by less technical team members such as marketers, project managers, and business analysts. Here, with the variety of data structures found in NoSQL databases, even simple NoSQL queries will likely require programming experience. This means technical staff will need to perform the queries. The next point is speed. Now, this is a crucial point, and here the speed of SQL databases compared to NoSQL depends on the context and use case. If you have highly structured data that doesn't change much, then SQL can be speedy. Here, retrieval time can be fast with NoSQL databases. However, if the database consists of a high variety of data structures, extra processing will be required and could slow down the things. Now let's talk about speed for developers. So SQL requires more upfront planning because modifications to a SQL database is difficult and resource intensive. Whereas here NoSQL flexibility allows developers to jump in and start building a database without spending time on upfront planning. Data integrity is another point where this is extremely structured nature of relational database tables leads to high data integrity, whereas NoSQL databases inherent flexibility and scalability comes at the cost of data integrity and security standards. The next is the dataset size, where the RDBMS better fits for a smaller volume of data and low growth, not well suited for large datasets or big data analysis. Here, dynamic schema and horizontal scaling makes NoSQL databases the right pick for big data applications and for managing large and growing datasets. The last point I would like to mention is the community. At almost 50 years old, the SQL programming language is extremely mature and still widely used, whereas this one is less mature than SQL. Developers have been using NoSQL databases for more than a decade and the community is growing very quickly for sure.